Welcome to the GeekConf. 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 Welcome to the GeekConf.
hundreds of resumes and conducting multiple interviews are time-consuming and resource-heavy tasks. But what if a tool could do this for you? Introducing Hyroscope.ai. With Hyroscope, you can create a JD and an interview in seconds. Let's see how it works. Start by creating your first interview on Hyroscope. Select the job role and key in your work experience requirement. Choose the skills that you are looking for and click on Create Interview. That's it. Your interview is created. Hyroscope.ai sets up an automated interview asking questions in the skill sets that you are looking for. With this, you'll also find that the JD for the job role is ready. Happy with what you see? Click on Publish Interview. Share the job position on LinkedIn, X, or any other job platform of your preference.
Welcome to the GeekConf. 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 Welcome.
Hey everyone, I welcome you all to the very first edition of our GeekConf. You might be wondering what is this GeekConf? Wait for some time. I'll tell you a fun story. Why did we start GeekConf? Basically, GeekConf is a 2-day conference. Our first day is today, that is 18th of July, and we are hosting it remotely. And then a happy news for all the people who love to join conferences from in-person real life. So we also have a day 2, that is on 25th of July. We'll be hosting our GeekConf live in Berlin. So yeah. So by the way, for the people who have not got the tickets yet for the GeekConf, I have a good news for you. I have a special code that is first 40. And if you apply that on a ticketing platform, you will get flat 40% off on the conference tickets. Isn't it a happy news? Go grab it soon till the stock lasts. I am very excited to host you all for this GeekConf, and I'm pretty sure that you all will be also excited for it. Now, since everybody is here, let me tell the story why we started GeekConf. So the story started long back in 2015. So our CEO, the CEO of GeekyAnts, he and his team is working on React Native ever since it is in inception. Today we are in 2024. A lot of innovations are happening in the space of React Native and modern web. So we decided as a team, why not have a conference and why not discuss all about this fun innovations in a one place. So that is how the idea of GeekConf came into place. So before we run down to the entire agenda, I have two very announcements for you. Yay! So first announcement is, any guesses what could be the first announcement? Since it's GeekConf, the announcement should be big. I'll wait for 5 seconds and then I'll reveal what is the first announcement. So if you have seen maybe the tweet sometime before the CEO of GeekyAnts, maybe you can get a hint from there. Okay, without wasting any more time, I'll reveal what is the first announcement. So if you have been working with React Native or in a space of React, I'm pretty sure you would have heard about the name GlueStack UI. We have also seen that GlueStack, right, which was running before this video started. So GlueStack is an amazing component library, which is accessible and very fun and easy to use. And we earlier had its V1, and now we'll also have its V2. So we are launching the V2 of this GlueStack library. It is already live on Product Hunt. You can go and check it out. It is super fun, super easy to use. And I'm pretty sure all the people who are working in React Native and the field of web development will love it. Yay! Now, coming to the next news, any guesses? Since the first news was related to GeekyAnts, the glue stack which they have built, now what could be the second news? A hint is that you have seen about this in the previous promo videos. I'll wait for 2 seconds and then I'll reveal what is it. So, just like we have launched GlueStack V2, we are also doing something fun. So we are launching a full stack universal template for Android, iOS, and then web. Now you might be like, oh my God, Smile, what are you talking about? We are in GeekConf and you are simply talking about a launch of starter. But wait, my friend, this starter is not just an ordinary starter, but it is a powerhouse. It can help you cut down 150 hours. Yeah, I repeat, 150 hours of your time which you would have needed to set up any application. Within 2 minutes, you will be able to ship some amazing apps. So we are launching a new suite of product that is App Launch Kit. So you can see about it more things on our website, that is applaunched with a k.it. And you will, I'm pretty sure if you love GlueStack, you will love this all. Coming to the main agenda of the day, we'll have some amazing talks, amazing and awesome talks by our amazing speakers. So I'll introduce one by one. to you. I'll introduce one by one to them with you. So I'm hoping that just like I am excited, I am enjoying this conference, you all will learn something from it, and it would have something for every role of people. So without wasting any more time, let me introduce you to our first speaker of the day. He's Matteo. He is an open source developer based out of Italy, and he's working remotely as a CTO and a CEO of a company called Platformatic. So he'll talk about something amazing about how to build apps using Autopilot. So please have a virtual round of applause and welcome our next speaker, Matteo. Hey, Matteo, welcome. Oh, Matteo, you're not audible. Can you check if you've turned on
Yeah,
your...
sorry. Hey, hi, Ismail. I'm very happy to be here, and fortunately, I couldn't come in person to Berlin, but I have been very happy to come and join you at this conference remotely. So that's good. I'm around. No, yeah. Thank you very much for inviting me.
Hey, Matteo, the stage is all yours. I'm excited to learn a lot about AI apps, how to build them.
Okay, great. So let's start sharing my screen so that and here we go. Yay. Okay, so you should be able to see my screen. Yeah, okay. So let's talk a few things about me, because I don't know, maybe you don't know me, or who is this guy talking on the screen today. So who I am the co-founder and CTO of a new startup called Platformatic. Been around for a couple of years, building Node.js stuff. I am part of the Node.js Technical Steering Committee. I also a board member of the OpenJS Foundation, created a bunch of open source, including library called Fastify, Pino, and a lot of other things. In my past life, I was a consultant in the Node.js scene. And I have a newsletter, nodeline.dev, if you want to check it out. So you're using my software. This is probably my tagline, either if you want or don't want it, you're using my software anyway in your life. I'm pervasive at this point. Last year, software that I maintain has been downloaded 22 billion times, which is maybe insane at this point. I don't know. So consider what it is for what it is. But you know, if I had 1 millicent for each, I would be very rich, and I don't, unfortunately. Anyway, so I am a backend developer by heart, and and you probably have seen that if you have been dabbling on backend work for a bit, that most of the time developers doing backend spend time doing anything but app work or business logic. They typically tend to do a lot of unspecialized work. Okay, so how can we do something about it? Well, 2 years ago, I started this journey of Platformatic to do something. Imagine that you want to go from one place to another, and you start in A. Okay, Platformatic helps both arriving at an intermediate location B, like if you had a very, very fast train, but also it allows you to customize everything and move very quickly to C, like you would have a car. Okay, and I think it's pretty good. And you can check out our dogs, and everything is there if you want to check it out. And we have a nice QR code here if you want to do it. Cool. So Platformatic service. Okay. So Platformatic is a suite of is a toolkit to build up APIs very quickly. One of those toolkits is called Platformatic Service. Platformatic Service is essentially all you need to build APIs quickly with Node.js. It's based on top of a framework called Fastify, which we'll talk a little bit about more in a second. It provides file system-based routing, like most of front-end frameworks. It also provides automatic metrics with Prometheus, but as well as event loop, memory protection, and as well as OpenAPI generation, if that's your thing, or GraphQL support. It's pretty cool, and it's compatible with all the ecosystem of Fastify. In fact, let's talk a little bit about Fastify. Fastify is one of the fastest web framework for Node.js. It's been downloaded more or less 7 million times per month, and it has 17 collaborators maintaining it. We are at version 4, and we are shipping version 5 really, really soon. And it has a massive ecosystem of 250 plugins. It's great. It's amazing. Okay. And it supports all the nicest things about the async await and all the goodies that you might want to consider. It also has an embedded logo. Note, the key part of Fastify is that the Fastify community is awesome, and it's a key part of it. Note that Fastify says that it's fast. It's probably one of the fastest things you can get for Node.js that is essentially butter included. On top of Platformatic Service, we have built something called Platformatic DB. Platformatic DB allows you to very quickly add storage to your systems. It's similar to tools like Azura or Supabase, but it's all written in Node.js, and you just run it on your machine, and you can heavily customize it if you want to. Something that's not as easy with those other tools. So you should check it out. We're going to use it later on. It provides automatic both REST and automatic REST OpenAPI routes, as well as automatic GraphQL routes. We also offer something called the Composer, which allows you to integrate multiple OpenAPI, multiple APIs into one. It's great, okay? And it works for both GraphQL and REST. And we do have something called the Platformatic Client, which is something very useful when you want to build a type-safe, full-stack client for your app. We have a version for the backend and a version for browsers for full-stack based on Fetch. But the key part, one of the key things that we do is something called Platformatic Runtime. Platformatic Runtime allows us to run multiple Platformatic applications into one single Node.js process, typically coordinated by a composer, but that's not strictly needed. And in fact, you can even write your own templates. Well, we don't call them templates. We call them stackables, because essentially you can stack them on top of each other. Okay. And so how does it work? Well, we have a thing called the marketplace, where you can choose and pick your own stackables. But you were here to talk about AI, right? And AI work. Well, talking about AI, one of those stackables is one of these things called AI work, and it's one of our stackables. And that's what we're going to use today in this very much live coding talk. After this, a little bit of intro. So AI work adds a unified API interface across all the AI providers, as well as a bunch of other features, including rate limiting, authentication, and so on and so forth. Okay, and we are going to use it with our tool Menahi. So demo time, and may the demo gods be with me, because this is going to be heavily demoed. Okay, so here we go. So first of all, we are open Menahi, which is our desktop app, and zoom in. Yeah, and we are calling the GeekyAnts. Okay, and we are storing this in TMP. So yay. So first of all, then we can select a template. We are calling this AI. This is our AI API. Okay, and we are going to load. You see, these are the stackables that I mentioned. We have Service Composer DB that I talked about. We have something called PGHooks and RabbitMQ for doing queues if we need queues. So we select AI work. This is what we are using today. And we are going to generate it. And if NPM gods are with me, it's going to take not so long. But we all know that NPM is probably not the fastest thing. And here it is. 30 seconds. Yes. Okay. Everything is stalled. Okay. Now we need to configure this. We need to choose our AI providers. We are going to use LLama 2. We are going to use a local provider, okay? Which I hope you enjoy. Okay. Oops. Sorry, I need to copy real path. Yep. With a local model, a Google Giga file. This is not needed. We are going to specify this. Okay. And we are creating our app. We're choosing JavaScript, hosting on the 3042. Okay. So all of this is going to use a local model. Why are we using a local model instead of one of those fancy AI providers? Well, you know what? You can run most of the AI stuff on your Macs. Okay, you just need a compatible CPU, and that would be good. So, so that's it. That's what we are doing. And it's we are generating all the things. Okay. Yay. Go to apps. Now we have the GeekConf here. I'm going to stop this previous version. This was my test thing. And yay. So we're going to this one, and I'm going to start it. Okay. Note that you see that we have our app and we have our services, which is the AI, which we just created. Ooh, yep. Sorry about that. I am on a bad internet spot. Okay. Now we have started our app. We can go and open this up. This is our AI verb. We can, for example, ask for an e-commerce schema, a SQL schema for an e-commerce. Okay, and we are going to ask our CPUs to do it for us. And it is. Okay, note that all this is local. It's not using any of the AI provider. We just put using a local model here, not even a big one. Okay, so you can get something good out of it. Okay, this is nice. And we can even open up the OpenAPI documentation. You can see that we have 2 bits here. We have prompt and stream. With prompt, we can just get a single request here. We can probably test these out and ask for something. What we want to ask, I don't know. Let's see. What are the titles of the Harry Potter movies? Let's see if it's good at this or not. Okay, you see all these demos will be movie themed. So yeah, we call it and ask. Working. Good, demo effect. Oh, yeah. Yeah, here we go. So we got the response. Took 20 seconds because we're doing a lot of Zoom that takes some time. And so you generate it all, okay? So we have the answer, Harry Potter and the Philosopher's Stone, Harry Potter and the Chamber of Secrets, Azkaban, Goblet of Fire, Order of the... Yeah, it seems pretty good. Okay. Okay, so we get all the answers, the correct answers to our oracle. This seems pretty cool, okay? Cool stuff. Okay, so we can do prompt, we can do all sorts of things here. Okay, this seems nice. Okay, so what are we going to do with this? Well, let's go back to our presentation and so on. I'm going to share this presentation before this is we need that thing. So what we have done, we have just added all those things. We can also use an OpenAPI key, and if we do, it will work the same, or Azure and so on. This is the exact same thing we've just done, okay, and so on, okay. So you can see this is working, perfect. Okay, now we have created this system, but it's it's just a very simple setup, okay. So what do we know? Can we do it more? Can we do something more with this? Well, let's start building a complex system. Okay, so what I want to have, I want to create an API, a simple API that stores me all my movies, is my movies database. And I want to create a microservice called opening that can give me the opening line of a given movie. Okay, and I'm using my composer at the top to join to expose those two. Okay, so if I want to do that, then I can just stop my app, and I can edit it, and I can add the missing things. So I want the DB, which we'll call it movies. Then I'm going to add my openings microservice, okay, which will be just a service, which is essentially the base what we are going to use for services. Then I am going to add our composer, which I'm going to call composer. Here we go, very easy. I'm starting it up, installing all the things, great. Now for the movies, we are going to use just a SQLite, but we can use Postgres and so on and so forth. We want migrations. Openings are nothing, composer are nothing. Yep, we configure the app, just use JavaScript. Yep, this is just, we're just generating all the files. Okay, we have not touched anything, any code right now. So far so good. We have just done all these bits. So then this is our app. Now we need to, yeah, this is that keep coming up. It's the out update that for some other reason. Yes, fine. Sorry about this. Okay, so we have all our systems, and the entry point is AI. So let's go and change a few things in our app. Okay, so we go in here, cd tmp thegeekconf. Okay, let's take a look at what was generated. So we have AI, which is our Oracle. This it just contains our config file, and it shows that we have a LLM 2 provider with the link to the model. Okay, and we can even configure the answer, the prefix and the suffix of our prompts if we want to do some configuration here. Okay, now in Composer we have Composer. We can compose our apps. So what we want to compose movies, as we said, okay, and expose it with a prefix of, well, with no prefix actually, okay. And here we have a default route, which we are going to remove because we don't need it, okay. So, and we are also going to expose another thing called, another service called openings. We have just created it, okay. Now, in movies, we have some migrations, which is our movie table, okay. And we have a default route again here, which I'm going to remove, okay. So openings is just a microservice. It has nothing in it. It's just an example thing. Okay, great. So I can go back to my Meraki, and I can, let's go back here. Oh, one more change I need to do. I need to change the entry point of my app, which is here. The entry point now is the composer, because we want to compose things. We don't really want to expose the AI service to anybody, to be honest. That is tricky, okay? And yeah, sorry about this. Okay, I can actually start this. This is by default applying all sorts of things, and it's running. We can see the logs. Okay, we can see that we just ran the migration of our migration, created a movie entity, did a bunch of stuff here. Okay, we can also have the metrics of my system and so on. So let's take a look at what was generated. So if we go localhost 3042, we have our movies, okay, and I need to zoom in. And we have our example route from my services. Now movies, we can test the movies route. There are no movies, so let's add one movie, okay. So if we want to add one movie, we can literally just add. Let's call it Star Wars. And yeah, we have created a movie here, and we can get our movies. We got our movies. Okay, so more or less this work. We can even have an endpoint to get a movie by ID. So here, if I can specify the required, which is 1, our ID, and we get the details of a single movie. Okay, great. So going back to our thing, we wanted to create a service that just get the movies and get the movie title and get me the given a given movie, get me the opening line of that movie. Okay, note that these we get all the stats of our system. Okay, ooh, here we go. What is it? Okay, so here what we are going to do is we are going to do into our services opening, and we can create a client. So we're going to use Platformatic client. So MPX, PLT, client, runtime, and because that's what we are doing, we want the AI system. Yep, and then we also want our movies. These will create us our movies, the two clients that we need. Okay. Copy and FG. Okay, so now we want to, you see we have created 2 folders. These are just the type definition, everything else is dynamic. So now we want to add our opening line, openings route, and this is movie ID. Okay, and now we can use our clients. We want to use AI, and movies. Here we go. We can get a movie. Okay, if we get a movie, we need to get request, movies, get movie by ID, and we need to pass ID. You see there is all auto completion here. So we get our movie. Then we want to get the opening of that movie. So we can do await, request, AI, prompt, that's the name of the thing, okay? And we need to pass in the text. Oh, no, it's called the prompt, okay? That's not true. What is the opening line of the movie? Okay. Respond, let's do a prompt report engineering with only the opening line. Okay, now as an answer, we are going to respond with the movie itself and the opening. Okay, let's see. We have created this, we are doing the 2 clients and so on and so forth. Okay. Let's see if I'm going back here, I'm refreshing this up. Now here we get the openings movie ID. Oh, pretty cool, right? The route already appeared. Okay, so I can open this up. I can put the value here, require movie ID. Let's try this up. Ooh, movies is not defined. Yeah, I made a mistake. Movies. Oh yeah, of course is movie. Here you go. And we get the answer very quickly. Okay, it's actually very nice. Okay, now we can even add data validation here, and so on and so forth. It doesn't require a lot of work, so we can want, to be honest. Yep. So we want movie ID type string, and is required movie ID. Okay, this is good. And then we want the response. Okay, which is what we want to specify. We also want to specify the tags, for example, and we can put it as movies. And if we do this, okay, and we refresh this up, okay, you can see now that we have these movies. Oh, but this is still bad. Why we don't get this? Okay, well, you can see it if this is part of the open API spec. Okay, so you can see that we have an operation ID and a summary. So the operation ID and a summary. So what we can specify here is an operation ID. Get movie opening by ID. Okay, and then a summary. ID. We refresh this up, and if we refresh this out, now it's actually pretty. We can actually have it pretty neat in our OpenAPI definition, and so on and so forth, and so on. Pretty cool, right? So we have essentially built a tiny little AI app just by combining two services together. And note that this works even if your services is remote or whatever. So you can do this kind of build this kind of APIs very quickly for your systems. And of course, we even have the stream capability. So for AI Warp, in case that's your thing and you need. Okay, let's do a quick recap of what we have done back on our slideshow. So what we've done is that we have added our application. We have added our stackables, the DB for our movie system, and then we have done the composer and the service for the openings, okay? And then we have done some editing on the platformatic.json configuration file of the composer to correctly expose the movies, only the movies and the opening systems. And we have edited a few of our routes, okay, emptied up the other two, and changed the entry point, which is the composer now, okay, created the clients, fundamental part. By the way, the client does not need, can run also without Platformatic. So if you just use the front-end one, you can use it even on inside your React or Vue or whatever system you're using, okay? And look, you can write the opening and in a much nicer, in a slightly different way if you want to, but genetically it would work too. And yay! And a few other bots that we are not going to cover with the demo. You can provide some authentication configuration in the system. In AI Warp, you can, for example, add authentication with AI with JWT and with all the secret JWT configuration that you can think of having. And you can even add rate limiting. For example, if you want to have a plan-based system that you have a certain number of tokens or times that you can call the API in a given period, you can absolutely do that with the max byte lane option, which is already built in. So I don't know, it's time for questions. Hello, hi, can't hear you, smile.
Yeah, let's wait for 30 seconds. I have a lot of questions. I'll definitely ask you. Let's see if people have any questions from the audience.
Amazing, yay.
Okay, I'll ask. So what do you think, Matthew? What is the role of open source projects? What role open source projects play in the advancement of AI technologies?
So this is an interesting question and something that I have that is pretty critical, okay? Every single time, like a lot of what we see now as AI system was built from the research community, okay? And all the work, all the academic work, all the papers, all the experiments, all the code has been for years released as open source, okay? Only the latest generation tools that have been commercialized are not open source. However, there are things, models, so there are technologies that are still open source, like LLama, the LLama 2 compile system and so executor, or Llama, but also models like Mistral that can be used openly, okay, without any limitations. That's what I mean. So frankly, I think that we will absolutely see a rise in the use of open source AI systems, mostly because it's essentially a basic factor of cost, okay? over a certain very low threshold, okay, it's actually cheaper to rent out some GPUs from cloud providers than using OpenAI or other of those tools. Okay, like people don't even like the order of magnitude is there's at least a zero in the between the two. Okay, so at least. Okay, so stuff that's not viable because of the cost of open API calls will it's actually possible already with just renting of GPUs and those things. Like it's fantastic to see. Okay, to be honest, it's you can just go online with a few provider in I don't know maybe 10 minutes. You have access to an H100 for doing all the things that you want to do. Now that's going to cost quite a lot per month, but it's compared to paying for each call in OpenAI. Well, the difference is going to be staggering. So yeah, I totally see an explosion. As long as the price of the GPUs and the power of those GPUs is going down, I absolutely see an explosion of generative AI apps out there and so on. Like as you saw, all this stuff that I've run today was run on my computer. Okay, while I was doing the streaming, I had a camera going. It's yeah, that's quite a lot. My only thing I did the wired connection of the headphones that for some reason scares my computer if it's Bluetooth. So I still have the mouse and the keyboard as Bluetooth. So anyway, yes, that's the gist. So yeah, no, it's great. Like doing AI stuff is open source AI is just going to grow and grow and grow and enable it for everybody essentially.
Got it. I have one more question. So what do you think? What are the ethical considerations one should take care of, while developing any AI applications?
So generically, when you're doing this kind of AI apps, if you're building an AI app, you are normally using starting off from a pre-trained model, something like Mistral, or using one of the API or one of the done by the major providers. This is great. Okay, so the biggest more ethical consideration are on them to some extent, because you need to they are the one that needs to be putting safety first, essentially, and preventing the genie to get out of the bottle, as they say. So that's the first one. However, there is a few more interesting considerations. So first one is you're likely going to be some training, some additional training on your systems. If you do that, then you need to be careful in owning the data that you're feeding the LLMs. Okay, these big models have been trained using certain data sets that might or might not. The law is still pretty unclear if they could do it in that way or not. Okay, there have been a few trials are happening across the globe. And there is some verification of, if the articles of the New York Times have been used to train some of the stuff, is it a copyright violation? Okay, where, there is these problems. Okay, so I would personally recommend to be extra careful and just train your AIs, your projects on things that you can use, okay? And essentially, And now for this reason, you have seen like a case came up recently and came out that, for example, Facebook was going to change the terms of conditions of all their products and said that they're going to use all the posts, all the images that you ever posted on their products to feed their AI training system, AI learning. Now, I'm not exactly sure if this is a good thing, because probably this AI system that you're going to use is going to learn a lot about bad stuff about humanity. So maybe it's not a good idea, to be honest, but that's what they're doing to avoid any legal problems. Essentially, they're changing the terms and conditions so that they can, but you have a way to always have a way to opt out. Slack have done something recently according to those lines. So the problem is probably the ownership of the data used to train is probably the biggest concern as an AI application developer. If you are developing a model or developing a system, well, there is a lot more to consider about safety there.
Got it. Thank you so much for your amazing answer.
Thank you.
And I loved your talk. It was such a nice one. Thank you so much for being an amazing speaker for us. See you.
See you. Bye bye, Smile. Bye. Bye 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 bye.
Moving on, we have our next speaker. That is, she is a web dev who works on React and Next.js. She is a consultant at Meta. So I ask everyone and I welcome Aurora with the virtual applause on our GeekConf, and she'll be talking about how we can make forms with server components. Hey Aurora, how are you?
Hi. Thank you for having me here.
We are super excited to have you, and I'm personally wanted to learn all about forms, which you are going to teach us. The stage is yours.
Thank you. Okay, I'm just going to share my screen here. All right, can you see this?
Yes.
Good. So good morning, and I'm excited to be speaking today to teach you about enhancing forms with React Server components. So this session is going to include mostly live coding with the goal of teaching you how to work with forms and RCs in practice. So first, about me, my name is Aurora. I'm from Norway, and I work as a consultant at Meta in Oslo. So I'm actually actively building with React Server components in my project, and it's very exciting to be able to share that knowledge with other developers. So let's begin by looking at the typical React single page application. It's great. You have your React query, React hook form, and all is well. But client-side apps have their problems. First, they run purely with JavaScript, right? So the entire application is constructed from JavaScript when the user opens the URL. When working with, for example, a slow device or a slow connection, it can take a really long time to download, execute, and hydrate the page to even fill out a simple form. And in addition, to submit data to a database, we would want a backend where you would want to validate the data, because you can't rely only on client-side validation. And even when with server-side rendering with, for example, Next.js, you might still have issues, because you fix your problem of blank screens by pre-rendering the pages, but you now have an even bigger dependency waterfall of server-side rendering the page, downloading, parsing, executing the JavaScript, and then hydrating the entire page before anything really works. And let's not forget the struggles of the Next.js pages router. You had to manually create your own API endpoints every time you wanted to safely submit a form on the server. You would want to use a library like trpc to ensure type safety. You also might have to write a bunch of excess, messy code, especially when you're dealing with errors and loading states. And overall, it was not a good experience. So now with React Server Components, which was announced in the part of at ReactConf as a part of React 19 RC, release candidate, we get server components. So React Server Components only run on the server, which lets us do a lot of things like fetch data asynchronously inside components. And we can access our backend resources. And we can reduce the bundle size because there's no JS sent to the client for these components, which lets us overall build very performant apps and maintain an enjoyable DX. So what we want to do is use React Server components to write performant, user-friendly forms without a lot of front-end complexity. And we're going to need a framework to do this because we need a framework for RCs, and Next.js is our pick here using the app router. Then we will be needing multiple other React 19 features that are available in the app router. That's going to be server actions, the form component, use action state, use form status, and use optimistic. So server actions are defined with use server and tells the framework like Next.js to generate a post endpoint to a function. And this allows us to call it from any component, for example, from a client component. It simplifies the communication across the server boundary while providing type safety using RPC. Then we have the form component, which is an extension of the native HTML form by React, building on top of its existing methods. The extension lets you create interactive controls for submitting information, as well as letting the action property call a function like a server action. And the server action called will be automatically an HTTP post, be wrapped in a transition, and then contain a hidden form data argument with the values of the form. Use form status is a hook that provides information about the last form submission. So use form status must be used inside a form component and can be used, for example, to disable a button or display inputted data while a form is submitting. This hook enables progressive enhancement because if there is no JavaScript, the button will still work fine, just not have any feedback. Then the use action state hook. So this hook allows you to update state based on the result of an action. It also supports progressive enhancement because when there is no JavaScript, it will still return the response from the server, even though it's not been hydrated yet. And it can be used to, for example, display error messages or other information. Finally, the use optimistic hook is another hook from React 19. And it's a hook that lets you optimistically update UI while a background operation completes. So it lets you keep the UI snappy by providing an instant feedback to interactions. It can be used with server actions and form submissions, but also with other potentially slow operations, such as filtering based on the route params. The hook stands out because of its ability to seamlessly merge client and server state as the server finishes its update. So with that in mind, we can move on to the demo. And I'm going to be coding something that I've made a version of for my current project where we use RCs. So let's go ahead with that. So I'm here in the Next.js app router. And my setup is Prisma as an ORM. I'm using a local database and Tailwind for CSS. And since we're in the app router, everything is a server component by default, meaning all of the components in this message box are actually server components. So I'm just going to look at those. So first, the message box component is a server component. It can be async, and it can also access our database right here on the server by getting messages from the database through Prisma. And then it gets the user, and it also maps the messages into individual message display components. And it's just displaying a message based on whether it's written by the user. All server-side, there's no JS here at all. And then there is a message input as well. And hold on, I'm just going to minimize the camera here. And this is also a server component right now. It doesn't do anything. It's a form with one input, and I can just try it out. Nothing's going to happen right here. So what I want to do is enhance this message box with React Server Components and React 19, where the goal will be to make this interactive while minimizing JS on the client and reducing the front-end complexity. So let's begin by making this form work. So I can use React extension of the form component to bind the action property to an action, like a server action. And I can call it submit message. And I'm going to create this inside my data access layer here. and just do submit message. And since it's going to be a server action, we need the use server directive so that this can be called from anywhere because of this post input that it has generated by Next.js for us. So I'm going to export an async function, call it submit message, and it will take in a form data object. And what this means is that each field in this form will be submitted with its value and the name that I've defined inside this form data object. So now I can use that to insert into my database. So I'm going to create a message where the data will be content from the form data. And I also need a created by ID. Hold on, I'm going to import this so we get the autocomplete. So I need somehow to pass an additional property to my submit message here. And one of the ways you can do that is by using a hidden input field. So I can define a hidden input field with the user ID value. I'm going to call this user ID. And now it's accessible inside the form data object. And I can close up and see what happens. So when I now submit this and manually refresh the page, I have a new message inside my database. And of course, I don't want to manually refresh the page, so I can use an API from Next.js called revalidate_path to tell Next.js to purge the server component cache and regenerate whatever is on this path. So now when I say, hey, it's added and refreshed automatically. So just by doing that, I have, without JavaScript, submitted a message to my database and revalidate the view. And if I'd been using the onSubmit here, I would have to be waiting for hydration to have completed for that to work. So there's something else I want to do here, because when I submit a message, my scroll bar is like up here, and I want to see whatever is the newest message. So I'm going to need some kind of interactivity. And what I will do here is change this container for the messages into an automatic scroller. And what this will do, is wrap a client component that can use as an effect an immutation observer to listen for events of a new child inserted. And since this is a client component, so it's interactive, it needs JS on the client. But when we're using a slot like the children property, we can render server components inside here, even though this is on the client. So the messages will still be on the server. So let's see first how it works. So when I'm sending a message, it's automatically scrolling to the bottom here for me. And when I check the React DevTools here, hold on. Let's go here. I can see that the only React component in the tree is the automatic scroller. There's no message display here because it's on the server only. So let's head back to the message input and validate the data here, because this is coming from the client. We actually don't know anything about what it's containing. We should be doing some validation here. So I'm going to say, I'm going to get a validation result from a message schema. And this is using Zod, which is requiring a specific shape and data type of our object. So the content has to be at least 1 character long. And we can use it to safely parse our form data object here, like that, and use it to insert into the database. And then we need to handle the case where it is not valid. So we can just throw a new error for now. And if I now comment out my client-side validation and submit an invalid message, we will have this error thrown from the server action. And you can handle errors however you want, but one thing you can do is use an error boundary. And I'm going to use one from React error boundary around the message input. So I can add an error boundary here. And it just says that something went wrong here. So when it fails, the error will be caught by that error boundary. But I'm going to leave the client-side validation and keep working on the server action. Because maybe, well, first of all, I don't really want to return, throw an error. I would rather return something. So I'm going to return an object with this error. And then I'm going to return just a success false. And I'm going to return a timestamp. And you will see why we're going to need this later. So let's create the timestamp. That's fine. And there we go. And maybe when you're doing a form submission, you want to check something in the database that a user exists, or in my case, how many messages the user has, so that we can limit the amount of messages the user can send. So I'm going to say messages for user will be get messages with the created by ID from our result here. And if this is, let's say, bigger than 5, we can say an error, user has reached the maximum number of messages, success false, and the timestamp. And if all is well, insert into the database, revalidate the path, and return success true. Like this. Oops, success true. And if something goes wrong with this database insertion here, we can just let the error boundary deal with that for us. So now I have a bunch of server-side logic, and I want to get the return value to the user somehow. So I'm going to use one of these new React 19 hooks, this time use action state. So that is use action state, and it will take in a function to call, or the action, which is going to be our submit message. And it's going to take in an initial state. And we can just say success false here. And what it returns is a generated component state, meaning a state that is equal to first the initial state, and then after that, the last return value of the action that is wrapping. And it also returns a wrapped action to trigger. I'm going to call it submit message action because that's the convention here. And when we put this on the form, the state will contain the result, the return value of the action. And then we can use that to, for example, show an error message. And I have a couple things I need to fix here, because first, this is a hook. It needs to, I need to tell the bundler to load the client for this component, load the JavaScript for this component on the client, like that. And I also need to fix some errors here, because use action state will pass an additional argument to the action that is wrapping, which is the previous state. And I'm not going to use that for anything, but I have to add it here. Previous state of type state. And I'm just going to make a state here really quickly and return a promise of that state. So now everything should be fine. Let's see what happens. Hey, hi. And since I hit my max message count, I will now have an error returned in the state, which will be showed here in the form, which is pretty amazing. So the next thing I want to do is make it feel a little bit more interactive and a little bit better. So I'm going to add an effect here to check whether the state has an error. And if there's an error, we want to toast an error with that error. And I need it to depend on the error, but also the timestamp, so that it will rerun whenever the timestamp changes. So if I now get an error from my action here, I will get also a toast message, which means I don't really need this error message on the bottom here. But instead of removing it, I'm going to leave it as a no script fallback, which means that in the case of no JavaScript, this will run. I think this is just gonna go away by itself. Okay, so another thing to handle is when I get an error, my field is being reset. And the reason for that is that with React 19 form actions and uncontrolled inputs, it will automatically reset when the form action completes. And this is a good thing because it kind of simulates this MPA form submission behavior. And if you use a controlled form state like reactive form, that's not going to happen. But we're going to use it, and we're going to handle the fact where we want to keep the value here. So what we can do is return also the value that was submitted, which is the content. And use this as the default value of the input, state content. And what this means is that if the state returns a content, it will be the default value of the input. And let's see how that feels now. So since it returned the content, my field has now been, is not reset. But what if I'm not using a local database? Maybe the trip to the server and back takes a while. It could be kind of slow. Well, it takes a while before I see that I even clicked this button. And maybe I'm like clicking it, sending multiple messages by accident, and I don't see that anything is happening. So luckily, use action state can also return a third value, which we can call is pending, which is the pending state of the function that's being triggered. And we can use it to disable the button. And maybe also say sending here when it's sending. So if it's pending, say sending, otherwise say send. And now when I say, hey, I will get the pending feedback while the action is completing. So if you worked with the Pages router and you remember having to make all the API endpoints and then using TRPZ to know what's happening from the server and dealing with error states and loading states on your own, this hook is now joining everything together for you and also dealing with race conditions that could be happening when you're doing that. Simplifying the act of submitting a form. So let me just increase my max message count to 8 here and try this form again. So I'm going to say, hey, I'm going to say send, get the sending feedback, get the automatic scrolling, and get the form reset. Now, if I turn off JavaScript, disable JavaScript, this whole form will actually still work. So let's see how that feels. No JavaScript. And I got a full page refresh, and I didn't get any loading state and any automatic scrolling, but everything still worked. No JS, still working here, and still no JS. And now I got this max message count, and it returned this error message to me, which has been shown by the no script fallback here. Let me just refresh this page here and see that we're back to normal. So what we've essentially been doing here in this demo is progressively enhancing this form, which means ensuring all the basic functionality works at the lowest level of resources, which is no JavaScript, and then adding functionality on top to enhance the user experience for the users with those resources available. So let's say a user is on a slow device, waiting for JS to download, parse, execute. This form will now work before any of that has completed, and we'll make the hydration for the JavaScript that we do want, which is the automatic scroller in this case, be faster because there's so little JS on the client for this component. So by weaving the server and the client together like this, we're achieving that. And depending on the user situation here, they will get a better experience, but always have a form that works. But there's something else we can change here, because I also want to show use from status, which is another React 19 hook. So the pending state is great here, but I'm reliant on use action state to get it. So I want to use a different approach, which is to create a reusable submit button. So I'm going to create a submit button and just say send here. And I want this button to handle the loading states for me. So I'm going to create this new submit button and a component and paste whatever I had in the previous component here. So I need a pending state, and use form status will give me information about the currently submitted form or the last form submission. It will give me the data submitted, pending state, the method, and the action used. So I can actually use this as my pending Boolean here. And use form status will kind of work as, we'll use the form that it's has as a parent as a provider to get this stuff. So I only need the pending state here. And this is also a hook, has to be a client component for this to work. And instead of just saying sending, we're gonna use whatever has been passed in. We're gonna make some props here, and it's gonna have children, and we're gonna get those to the component. And if it's pending, we will render a nicely styled div and put a spinner here. And then we'll put the children. And if it's not pending, just render the children. And you can make this even more reusable by saying loading as a additional Boolean to trigger the pending state or to trigger the spinner, or you could extend the button props, but this is fine for now. So let's try to import this and see if it works. So I'm gonna say, hey, and now it's rendering this nice spinner the same way as before, but it's all inside the submit button. And what's so great about the submit button is it can be just thrown into any component and it will handle everything that it needs to do on its own, meaning it's very composable. So if I go to my message box and let's say I want to reset the messages, I'm going to just throw that in there, add a form with an action where I can say reset messages and wrap it. And I'm just going to do an inline server action here to make it fast. Reset messages, async function. It's going to be a server action. It's going to be slow so we can see the spinner. It's also going to, delete many from the database. And it's going to revalidate the path. And let's try it out. So the form is bound to the server action to clear the database, and the submit button should hopefully handle everything, even though we're now in a server component. Let's just try this. So it's spinning, and it cleared my messages, just like that. Now, I'm also gonna jump over to a different branch to show the use optimistic hook. So let me just get rid of all this code and go to my optimistic branch here. So here, I've not made a lot of changes, but I've made a separate messages component, which is containing the use optimistic hook. And what this does here is it takes in a state to show when no action is pending, which is the messages from the server, and an update function that defines that when an optimistic message is added, it will give that message an is sending set to true. And it returns the optimistic state and a function to trigger the optimistic update. And I'm using it to show optimistic messages and then passing down the function to update or to add an optimistic message. And finally, I've added one onSubmit function here that will be called instead of the action when the form is hydrated, meaning it's also a progressive enhancement of the base case of the form. And it adds some optimistic message and awaits the actual action. So let's see how that feels now. Hi, or hey, sending. So that's the optimistic update. And then as the server is done, it will settle to this server state. Sending, sending, and then they settle because the server has finished its update. We can try a few more. They're all sending, and then they return from the server. And as I hit my max message count, the message that was optimistic is automatically removed because it doesn't exist in the server state. It's only in the optimistic state. So, of course, depending on your app, you can decide how to implement your forms and whether you want your React hook form still. That's completely fine. Or you can decide to use these more primitive features of the web together with React 19 and React Server components and make very robust forms while maintaining a great user experience. So that's pretty much it for the demo. I'm going to jump back to my slides here. It's also worth noting that actually submitting forms with actions is not a new concept in the meta framework world. Remix has been building on the principle of progressive enhancement ever since they released the framework and enable it with their loaders and actions and focus on web standards. And then there's SvelteKit and Nuxt, which have somewhat the same thing. But of course, each framework has a different implementation and features and developer experience. So the good thing is that what we've been learning here is applicable outside Next.js as well. However, it's worth noting that the Next.js way with the server actions stands out from the others because it separates the action from the route. So this is the repo for the code that I just wrote. And the optimistic version is in a branch. And for references, most of the stuff I've shown here can be found on either the React docs or the Next.js docs, where the React docs contain more in-depth explanations and has a more focus on the client side of things. And just message me on Twitter if you have any questions or anything. Thank you for having me, the GeekConf.
I was speaking. I was saying, thank you so much. That was
Thank you.
Amazing talk, and the demo was amazing. It just blew away my mind. I have a few questions.
Yes.
What design patterns are most effective for building scalable and maintainable forms using React Server components?
Is the question, can I read it or can you repeat it?
Okay, so what design patterns are most effective for building scalable and maintainable forms with React Server components?
Okay, so I would say that especially this pattern of using a use from status to you can, have this composability with a form being at some level of your tree and the submit button handling, or it could be any component in your form handling the pending state or displaying the data submitted is a design pattern that you can use, which is kind of just following React's composability pattern, right? Yeah.
Okay. One more question I'll ask. So are there any open source projects or libraries you would recommend for working with the React Server components and forms?
Okay, so there's a couple form libraries. Of course, we're still early in the development here, and actually these hooks they can be used on their own, but they can also be thought of as primitives for other library authors to create things on top of it for us normal developers. So there's like a couple different ones. Yeah, there's one called, well, this is not really for forms, but Next Safe Action. It's built on top of use action state, or it's kind of a replacement for use action state. Anyway, it will abstract away some of the problems that you will encounter. And I know that the creator of React Query is working on TanStack Form, which is also trying to implement these things. And then I think also TRPC is working with these new hooks to try to create some good tools for us normal developers.
Got it. That is fun talking with you. Thank you so
Thank
much
you.
for being
Thank
part
you.
of our conference.
Thank you.
Moving ahead, next up, we have an amazing speaker. Again, he is Matheus. He is a senior software engineer at Idilda, and he is also a mentor at Tech Labs. So, with all our virtual hands, let's welcome Matheus, and he'll talk about Atomic CSS.
Hello everyone who's watching the GeekConf. I'm Matteo Albuquerque, and today we're here to talk about Atomic CSS. So yeah, let's get it started. You can find me everywhere as Y Combinator, and here's our list of topics for today. We're going to talk a little bit of what I consider to be a couple of bad takes overall on this whole thing of Atomic CSS and Tailwind and a lot of things you're probably aware of. Then we're going to have a brief overview of what's, in my opinion, really good about this approach to writing CSS, what's bad, what's ugly, and a couple of good measures that we can have to make our lives easier when writing Atomic CSS, when working with technologies like Tailwind. And then we're going to have a couple of closing thoughts. Before we get started, I do have an intermission, so let's discuss a little bit about Atomic CSS. So one of my favorite definitions out there is that Atomic CSS is the approach to CSS architecture that favors small, single-purpose classes with names based on their visual function. So this means going from something like this, where we have a div and we have a class name that goes by car, and this class is what's called thematic CSS, into this where we're describing the overall appearance of this car. And before we start the session, I also want to propose the mental exercise for those who have worked with Atomic CSS, be it Tailwind, Geekyants, or whatever flavor of Atomic CSS. What was your experience? For example, did you find it easy to reuse or perhaps hard to read, or you overall loved it, or you agree with people who consider it an anti-pattern, or maybe you think it brings consistency, or you have some neutral feelings? Take a moment, think about it, and we're going to revisit that in the future. So I want to say that I want to have some sort of good, bad, and ugly approach here for the rest of the presentation. And I want to, as I mentioned, start with what I consider to be bad takes on the topic. So the first one, and probably what you hear out there the most, is, what about inline styles? You might as well write inline styles instead of Atomic CSS. But with a few things that are not taken into consideration here is that first, it is surprisingly costly for the browser. So it is really, really heavy to convert those strings to the native representation of the platform. And also setting styles via the style attribute is going to cause reflows and etc. The second thing is that those can handle media queries or pseudo selectors. And another thing is, you don't have to follow overall any pre-existing definition when you're doing inline styles, as opposed to when you're doing Atomic CSS and you have a finite, very well-defined set of classes. And that's exactly what Atomic/utility classes are, a very well-defined API that can act as a single source of truth. So not the same as doing inline styles. The second thing is, it bloats the HTML and makes your page heavier because you're writing thousands and thousands of class names. But nowadays, we do have algorithms that are focused on text, on strings. And one example is the deflate algorithm. And also, the more a selector is repeated across a style sheet, the more work the browser has to do to resolve all the styles. So that would be also a perf issue. This one is also super popular. So what about separation of concerns? So I think that we need a paradigm shift here, because the style sheet composition is performed in the HTML, but you're not using style, aligned, width, height attributes. These are more like pieces that are assembled from a style sheet that is written in CSS, and the HTML is just this consumer of CSS. Plus, I think that this usually comes from a very, very extreme vision of what separation of concerns is, that sometimes is very, very impractical, if not dogmatic. And another example of this is the Vue.js official documentation. They even had to add a specific section on addressing separation of concerns and how this doesn't mean, for example, separation of file types. Not to mention that there are a lot of other arguments that people usually come up with when talking about Tailwind or Atomic or utility CSS in general, and a lot of them have been dismissed already. And I think that we can move to a point where we see that Tailwind has potential to alleviate some of the concerns that are outlined for Atomic CSS and also provide some intriguing benefits. And we'll eventually get to discuss these. So what I consider to be actually good about most of the flavors of Atomic CSS out there is that first, conciseness. So whereas developers are always trying to write code as efficiently as possible, and CSS is one of the things that still requires a significant amount of code, even in an era where we have preprocessors. So I would say that Atomic CSS allows developers to write significantly smaller rules. And one example of consistency, and that's very, very, it's of course just one example, but is when you're writing a div and you have to, or some container, and you have to work with media queries and etc. That's some interesting and fairly common layout and logic. And this could be converted with Tailwind, for example, into this. So it is concise in a sense. The second thing is how these frameworks, and I'm not only talking about Tailwind here, but how they play well with component-based frameworks. And we're sort of in an era of component-based frameworks like React, Svelte, Vue, or even templates. So because these component-based frameworks, they, amongst other things, they do solve the problem of repetition. And in my opinion, this plays really well with Atomic CSS in the sense that it makes it easier to create encapsulated component-based styles. So I find it to be a nice match. And speaking of encapsulation, that's the next topic. So styling is contained in classes, and it only applies to element with those classes. So you as a developer don't have to worry about accidentally breaking something when modifying a rule in a particular class. And I would go one step further and say that you even get some better specificity and clarity, because each element can have its own classes for particular needs. And of course, consistency. So consistency was even raised and disposed by Adam, the creator of Tailwind, and viewed from a particular perspective. The predefined values offered by this approach can have very, very real world benefits across projects. And this could vary, for example, if you're an enterprise scale company with dozens, if not hundreds of teams, for example, or a small startup was constantly onboarding new people. So yeah. And then other things like reducing the overall amount of CSS, because it has been proven that at a large scale, Atomic CSS can, for example, reduce the overall the amount of overall generated CSS. And even the whole culture of copy and pasting markup, I would say that this has a very, very beneficial side of things. We're going to discuss the bad side of it, but I don't think people appreciate how powerful it is to be able to just move a bunch of markup code to another file with no further changes, no extra imports, no class renames. And in my opinion, this is one win over CSS modules or other approaches. So we can now move to what's bad perhaps about it. And the first topic I want to discuss here with you is a non-technical one, actually. It are the bad claims around there. So the first one is actually from this post. I think it dates back to 2013 and was one of the first posts on Atomic CSS in general by the creator of a very, very popular Atomic CSS library at the time. And you see that it goes as simple changes to the style of our module have resulted in new rules in the style sheet. And that was proposing that this is something that goes wrong. But if you think about CSS, you're defining the style and layout of a page. So it is okay that modifying the appearance of a UI element requires changes to the CSS. It doesn't have to read as a bad thing. And by the way, this doesn't always mean create a new rule. If we go forward in the same post, we're going to see something like good names don't change. You see that this argument is about maintenance, not semantics per se. But I think that the only difference from a maintenance perspective, if we compare to other approaches like semantic CSS, is where you make the change rather than whether this change is even required in the first place. So we're talking here about changes restricted to CSS versus restricted to the HTML. So I don't think that Atomic CSS is doing any better here. And also, while the class names remain unchanged, you still need to modify the contents of the class attributes as this is your CSS, but in your HTML. So that's another example of a bad claim, in my opinion, that I see circulating a lot around Atomic CSS. And then fast forward in time, we also have some claims coming from the Tailwind community. So I don't know if the web pages is still like this, but for a lot of time, they had this rapidly build modern websites without ever leaving your HTML. And I think that there's a dangerous assumption being made here that is switching between HTML and CSS all the time is a pain. But bear with me, if you're tweaking markup constantly while you're working on the appearance, it probably means that you're treating your markup as an extension of CSS rather than the markup for the structure of your document. And again, this goes on, so you'll find other claims that they don't sound really great. And I think that all of this builds up to belief or culture that Tailwind is the future of the web development and that it represents the single correct way of doing things, when it's not. Like, there are great cases for it, there are cases that are not so great. So the next point here is what some people call the utility CSS lock-in. So one exercise we can do here is think, if we want to go from semantic HTML/CSS towards Tailwind or some other Atomic approach, what we would have to do is to break our compound semantic classes into Atomic utility ones that would carry single responsibilities. And despite being a considerable effort, that's a fairly easy thing to do. Not to mention that there are even tools out there capable of doing this, like Wendy. But if we want to do the opposite and actually go from Tailwind or some other similar library towards semantic/atomic, towards semantic HTML, CSS, it's really hard to picture a tool that would do this, because you can't really build anything that's more complex without assembling those classes by hand. And to be honest, you probably could only convert Tailwind into some other utility CSS-based framework. And if you were to move to any other framework or preprocessors, that would be a considerable amount of refactoring. And even though I know that most of us are constantly swapping out CSS frameworks like on a regular basis, it is an important consideration for apps that are meant to be maintained on the long run. The second thing is more Tailwind specific, but that can also be extended to others that are missing key CSS features. So almost 2 years after its initial release, Tailwind CSS still didn't support pseudo elements or other CSS features, for example. And the case for pseudo elements is that it's something basic to CSS, and actually a lot of other preprocessors have supported it for years. And we can find other occurrences of something like this. So for a while, that was background gradients or animations or pseudo selectors. Now we're talking selectors like is and where, or new functions that get into CSS like min, max, and clamp, or pretty much any other bleeding edge CSS feature. There will be a barrier where it's going to be considered a missing key feature in tailwind. And then number 4, it's also more tailwind CSS specific, is how class detection goes there. So if you're not familiar, tailwind doesn't really parse or execute any of your code. So it actually uses regexes to extract every string that could possibly be a class name. And it will only find strings that classes that exist as complete, unbroken strings. So because of this, you can't really construct class names dynamically, which is a fairly common thing to do in a lot of frameworks out there, React included. And and by the way, this is even highlighted in their documentation, do not construct class names dynamically. Okay, so now we can move to what I consider to be the ugly about it, and about not only tailwind, but about this whole approach to CSS itself. And the first point is how hard it is to scan things. And I think we can have an example here. So if we have this piece of CSS that, by the way, could be written in any atomic/utility first approach, and we want to add more media queries to it, this could easily go into this, for example. So that's a very, very huge line that I'm not even sure if you can read it in the presentation. If we compare this kind of thing with a traditional semantic CSS approach where we have our class and then we have our separate media queries, now let's say we want to track down a UI bug, and we know it's not in the tablet/desktop version. So we can simply ignore these blocks of media and just focus here and scan what's here. And I think that it all goes to the fact that it is simpler for us humans to scan if we only need to read code from top to bottom. Plus, it is easier to find specific property value pairs. And proper syntax highlighting, that is separating properties from values, also enhances readability. And one could argue that on a daily basis, we wouldn't be facing that kind of scenario where we have dozens and dozens of class names. But if you do inspect production applications like Netlify, you're going to find actually that this is super, super common. The second thing is somewhat an encouraged tag subculture. So I think that this all comes from the fact that the focus here is on the classes, not on the markup. And don't get me wrong, it's not that Tailwind promotes ugly HTML at all. They don't. But it just happens that you as a developer can throw in as many divs as you want, and you don't have to care about their meaning. And in the end, you can do things the right way, but the ergonomics are kind of just lean towards like deeper and deeper DOM structures. And you can even find this kind of example in Tailwind UI. And this is actual markup for a simple footer in a Tailwind UI template. So if I were to come up with a hot take from here is that I think that the problem is in thinking in CSS classes first, rather than starting with the markup and working the CSS from there. And tools can make it easy to do certain things the wrong way, and that's not only about Atomic CSS or Tailwind, or it's a broader problem. And I think that what happens is that this approach makes for semantics just the easiest path. And I think that Tony summarizes this really well here. So the problem is that I need somewhere to put my class. Let me the additive mindset is far easier to fall into in Tailwind. Yeah, it's a problem elsewhere, but I continually see it as a side effect of Tailwind's structure. So I think that what could be going on here is that you might end up optimizing for developer happiness and productivity over the readability or maintainability and perhaps even the accessibility of your code. So there are a bunch of other examples in all the Tailwind repos, Tailwind UI based, Tailwind CSS based repos with different UI components like this one, where you find like an endless div soup, you have empty headings, you have placeholders being used to do the labels job, you have spans that should be headings, and so on. And if that's a single component or just a few components, yeah, that could be fine. But if you're doing this at enterprise scale, this could quickly escalate into having an actually excessive downsides, which, by the way, is reportedly a not so great practice. And one could think that this doesn't really make much of an impact, but it does. And we often have reports like this performance inequality gap from last year, where you can see, for example, the impact of like really, really large DOM structures to what they can make to users. The third item here are the developer tools experience. And I think that the first thing is that it is hard to find components. So when you're troubleshooting a large code base, you probably want to be able to narrow down the affected component. And when you have a close mapping between the component name and its class name, it is easier to find the relevant code really quickly. But if we're talking about Atomic CSS, we only have two options. Either we have knowledge on that particular area of the app, or we're searching for specific strings. But the thing is, not everyone on the team may be familiar with every component in the code base, especially if you're a new hire, or again, if that's an enterprise scale monorepo, for example. And when it comes to strings, they can simply get reused across multiple components. So if you're trying to quickly find those, searching is going to use a lot of results that are not the ones you're interested in. And then, and thus, it's hard to determine where a module starts and where it ends. And by the way, this kind of problem has been reported like for a while now. There's even this post by Adam Silver. It's called The Problem of Atomic CSS, and he highlights it really well with other Atomic CSS initiatives that are not Tailwind. And the second thing is, it's also hard to tweak CSS. So as a front-end engineer, making certain tweaks through the dev tools in the browser is a common practice. But here, you need to give each component a new class name and use that as a selector. Or you can use inline styles, but you won't see how it's reflected throughout the whole UI. So it makes it harder to sometimes make some small tweaks. I know I did go through a couple of things that are considered not to be great or even problematic about Atomic CSS, but the good news is that some of them can be mitigated with tooling and other practices. So I'll start with the basics, that is this whole idea of on-demand generation. So if we were to do a mental exercise on how we can generate Atomic's class names for margin, and let's simulate this using a CSS preprocessor. So if we run this, we're going to get m-1, m-2, and all the way up to m-10. But the problem here is there's quite a huge mismatch between what's generated what you actually need for your app, what you're shipping. And because of this, you end up having to, for example, purge CSS that ends up being wasted. So you have a necessary computation because you generate things but not use. And at the end of the day, you might still be unable to satisfy your needs. So we can go from this scenario towards on-demand generation. That is, by the way, what's this current state of art for Tailwinds, where the tool is going to scan what you're using and then generate on demand, and what you're shipping, it's very unlikely that you're going to have to purge anything. Since Tailwind 3.0, the state of the art is to use the just-in-time engine. And if you're using version 2, you can also enable that via the mode option. You can put mode to JIT, and other tools like Uno CSS also allow you to do this, also ship with this. The second thing I would highlight here is be aware of the apply directive. And that's not only me saying, even Adam, the creator of Tailwind, has mentioned that the apply is more of a sketch app and you should almost never use it. And I think that most of the time when you're using it, you're negating the benefits that you got by using Atomic CSS in the first place. So you're missing the explicitness of the class name, you're missing the time saved by not having to write your own CSS, and you're missing a very important thing that is your single source of truth. And you're going to see a couple of posts out there recommending that using apply to mix and match semantic CSS with atomic CSS, for example, could be a good idea. So this means, for example, having something like this where you have G wide and padding large utility class names, but still have a card. But I do see a very extremely destructive potential here. And you're kind of using, and one thing that could happen here is that you would use functional classes as an escape hatch to undo the rules of your component. So strive to be extremely strict with the application of both so that they do not intersect or share concerns. Another thing is type safety. So I've seen out there a lot of people that the main barrier for them to really love to win is some sort of missing type safety, or they would like to get type safety as you would get with other approaches like CSS and JS. Fortunately, nowadays we have solutions like Tailwind, CSS class names, and even Typewind that are really, really great alternatives. They have everything you would expect for a TypeScript solution. So there's zero runtime, you get out of completion and the whole type safety. There's no extra needed editor extensions. And at the end of the day, you are catching errors at compile time. So do check this out if you're not using it. Another thing that comes out really handy for maintenance, especially if we're talking again about a large code base, is the style sheet composition. Are some ways that you can do to compose style sheets. So the first one is Tailwind merge, and that's really helpful when you have to handle simple style sheet composition scenarios here. So you can, on top of the create your own class names function. Here I'm using CLSX and Tailwind merge to create a custom class name. And then across my UI, I can just use, for example, here in this input, class name equals to class name, and it's going to solve conflicts. And for more complex scenarios, I do recommend a lot CVA. So CVA stands for Class Variance Authority. And here's an example where I'm using CVA to basically model the different states, the different variants of a button. So it can have different intents. For example, it can be primary, secondary, etc. It can have different sizes. It can have different configurations for roundness and etc. And so it looks like this. And you can even define some default variants. So you can say that the default size is median, default round is round. And when you're creating your UI components, you can then use the variance object, the variance function you created, and then pass down all the props you got from your React component, in this case, intent, size, roundness. So that's really, really convenient. And that at this point, you probably notice how a lot of these things are actually about tooling. Tooling. So that also goes for linting and formatting. So a lot of the things that we discussed to make it even harder to visually scan a whole bunch of class names can be addressed by using some ESLint plugin or Prettier plugin, and etc. Also, some of the missing things that we discussed about Tailwind, like Clamp, they can come in form of plugins too. Not to mention a lot of things like accessibility. You do have a lot of open source mixing and matching Tailwind CSS with Radix, for example. And you can also use tooling that goes beyond Atomic CSS in the first place. So you can integrate accessibility into your build process and catch errors as you build out your app using things like Xcore, DSX accessibility, Lighthouse audits, and many more. And you can even bring in those tools to your CI, be it to your CI, whatever solution you're using, like XLint or XSLint. And then you can have like some, okay, not all of issues, but you can have some accessibility issues being caught as you as you come up with your PRs, for example. So that's really good. That's really good. And also the right way of doing Atomic CSS for you might be another flavor of Atomic CSS, that is Atomic CSS in JS. So there's this very, very good post that's called the shorthand longhand problem in Atomic CSS. It was posted back in 2020. And I do agree a lot that the author highlights that one of the good points of Atomic CSS in JS is being able to write your styles in a familiar monolithic way, but getting the Atomic CSS output with what for some people is what they're looking for, like increased reusability and decreasing the final CSS model. And there are a lot of good talks on the topic by Nicholas Gallagher back in the time when he was writing React Native Web, or also Facebook has this internal tool that is also based on Atomic CSS and JS, and they even have talks on ReactConf about it. Not to mention a lot of other open source tools like Fella, Styletron, UIBox, Compile CSS and JS, and many more also are based on this whole premise. So you definitely should check it out. So before we wrap up the session, I do want to share a couple of closing thoughts here. So you're going to see out there a lot of posts summarizing this whole discussion around Tailwind CSS and Atomic utility CSS approaches and all of that. It's just developer drama and arguing that your users, they don't care about which tools you use and etc. And I do see where this kind of thing comes, but you'll also find out there too posts written by engineering teams who decided to use something like Tailwind, and this ended up being a bad decision for them, so they decided to revert it. And that's not because Tailwind per se is bad, but it was a decision that didn't work for that team. Not to mention that you're going to find even entire tools dedicated to this, like Vanilla Breeze, that's meant to try to convert Tailwind CSS into semantic CSS. So yes, it is just a tool, but I also think that using the right tool, making the right call can make a huge difference at the end of the day. and that huge difference might be impacting for your users. The second thing is also, as you probably noticed, the solution to a problem basically, and most likely will only change the problem that you have. So yeah, a lot of things that are about thinking and considering and making smart calls about trade-offs. The third thing is that even though we talked about apply and being aware of its trade-offs and this kind of thing, utility classes can coexist with other approaches, and the sweet spot for you might be a hybrid of different conventions. So for example, you find that Bootstrap and actually other libraries, there's a whole host of utility classes offered, but you'll also find traditional components, and a lot of frameworks are taking this mixed approach. So if you're doing it, it doesn't by definition mean that you're doing it wrong. Also, I think that Tailwind, just like a lot of other tools, they suffer from people thinking it applies to all projects. So, for example, Tailwind's biggest use case is component-driven development. That alone resolves most of your issues. But for example, I wouldn't use Tailwind unless I'm taking this approach. So a lot of people are going to complain about repetition because they're not in a component-driven scenario. And yeah, and also there are more examples like support for web components and Shadow Dawn and how this all goes with Tailwind. But the thing is, they're encapsulated in global CSS classes won't have any effect inside their shadow root. And that's, by the way, the whole point of encapsulation. So all this to say that you think that if Tailwind, you try to think and reason whether Tailwind, whether Atomic CSS in the first place is the right approach for your project. And by the way, this whole discussion out there reminds me a lot of this post by Guilherme Roch, the CEO of Vercel, where he says that the most successful technologies on the web in recent years, and then he says React and Tailwind start out being dismissed on the basis of syntax aversion and not separating constraints. And I think that yes, JSX created a similar feeling amongst developers worldwide, because at the time it was going against so many best practices that it could be never considered a good idea. And back to the question that I asked you at the very beginning of the presentation, if you were to summarize your experience with Atomic CSS, what would you say? I have asked this very same question in meetups and other places where I've had the chance to talk about Atomic CSS. And here's a sample of the kind of responses I get. So you find very, very negative sentiments like repetitive, hard, lengthy, gross, unclear. And you'll also find people who love it, who consider it very interesting, amazing, easy, hard, good, nice. And that does reflect really well what's going on in the internet around this topic. So all this to say that I think that there's an emotional side to a lot of our tech choices as developers. And in psychology, we call this courage and passion, something like team identification. And I think we should try our best to run from this and really think from a rational perspective, try to reason tech choices like adopting or not Atomic CSS, adopting or not Tailwind, and etc. By the way, this is me. I am Matteo Albuquerque. You can find me everywhere as Y Combinator. I'm a senior software engineer in Medallia. I'm part of the React Summit New York City committee, and I'm a Google developer expert in web performance. Thank you for having me. The links to this session and other sessions I have on performance and journals of the tools, case studies, etc. are available here. Thank you so much, the GeekConf. It was a great pleasure. Bye-bye.
That was a wholesome presentation. I just lost track of time seeing the amazing presentation. Thank you so much, Matthew.
Thank you.
Questions. So what challenges might developer face while adopting atomic CSS? What do you think?
I would say that really depends on which context. It's a classic, it depends. So perhaps it depends on which context you're coming from. We could be talking about process and culture challenges in the sense that that's, by the way, the reality of the company I work at right now. We have a lot of legacy code bases that they are using SAS or other preprocessors, and pushing technical lift initiatives is just not that simple. So you might have selling issues trying to convince people of adopting it. That's one thing for sure. When it comes to but then again, it depends if you're working at a startup or yeah, that really depends on where you're coming from. As to technical issues, I don't know. I guess that a lot of what I've seen happening are parts of the team unhappy about certain things when it comes to atomic CSS. So not adopting the proper tooling, for example, and this kind of thing. So sometimes lack of tooling, like if you're not experienced with atomic CSS, so if Tailwind, for example, is your first approach to atomic CSS ever, then there's a whole curve, traditional learning curve that I don't know you wouldn't have if you've done the Shayan back when it was a thing, or even Bootstrap utility classes and etc. So yeah, perhaps lack of tooling, lack of culture in the company. Yeah.
Got it. So what do you think? What role design system play in the conjunction with atomic CSS?
I would say it's perhaps the other way. One question I've gotten in the past, and I actually was at a meetup the other day, and people were not convinced that atomic approaches. We were specifically talking about Tailwind, but atomic CSS in general, in the scenario where you would have utility classes and etc., were not ideal for building a design, for implementing a design system library in the fence, like a component kit or this sort of thing. Then I think at the time I grabbed Shayan UI and showed how they organize code base, and actually they were not aware that there is so many React tooling and that it would play so well with Atomic. So it's more like I don't think you need Atomic CSS to build a design system, or the other way around. It would probably good in your design system, either if you go with semantic CSS, Atomic CSS, if you go with a Tailwind, or if you go with some other thing that's post CSS based, etc. You should be mostly good, unless of course you have some technical concern around performance, accessibility, etc. But the point is, when I noticed pushback on the design system plus atomic CSS, it's mostly that people are not, and mostly in the React community. I don't know how this really goes for Vue and Svelte and others, but people using React and pushing back on Tailwind is mostly because they were not aware of things like CVA or similar. So they ended up seeing the whole thing becoming really complex and snowballing into something that would be hard to maintain, when actually it doesn't have to be like that.
Got it. This answers my doubt. Thank you so much for being part of the GeekConf. We were so amazed to have you. Thank you so much.
Thank you for having me. It's really great.
Moving on, we have our next speaker. So our next speaker is Rajat. He works as a product lead in a company called Hashnoon. He'll be talking about what will happen when Gen AI meets open source. Over to you, Rajat. Let's welcome with a huge round of virtual applauses to Rajat. Hey,
Hey,
Rajat.
hello everyone. Thank you, Smile. Thank you for the nice introduction. Hello everyone. It's great to be here. Thank you all for joining us today. It's a pleasure to talk to all of you alongside such brilliant speakers. So, yeah, I think we can get started. Let me just share my screen. There you go. All right. So today we're going to speak a little bit about Gen AI and how open source has impacted it and how it's continuously evolving the whole ecosystem itself. So let's go a few years back. OpenAI just released GPT-3 and we were all collectively mind blown with its capabilities. It felt like magic and something that we had just seen in books or movies. And then came DALI, and it was painting our wildest imaginations with pixels by just giving it an explanation of what we want to see. And with the launch of ChatGPT, suddenly everyone from your young nephew to your old grandma who was just engaging in conversations with AI just on a daily basis. And it started feeling very regular. But at the same time, the open source world was also busy democratizing AI, creating powerful alternatives. And today, we have reached a point where some of these open source models are not just catching up to their proprietary counterparts, but they are sprinting ahead. Time for an introduction. I'm Rajat Kapoor. I'm the engineering lead at Hashnode. It is a blogging platform and community for developers. So if you are looking to start a blog or if you already write a blog, please go ahead, check out Hashnode. Or if you're just looking to consume some engineering content from a wide variety of people, you can check out hashnode.com. So I have been fascinated with generative AI since it became popular. And now I use it to help me with all the tasks, be it work or otherwise. And today I'm here to share about how you can also leverage some of this open and accessible tech in your daily life. So let's get started. Let's start with talking about open source and how what it generally brings to the table whenever it enters any particular technical domain. So the first thing is accessibility and democratization. So open source allows broader access to a large group of people to a particular technology. It's essentially you do not have to sign up for waitlist, you do not have to pay, you get access on the day things are released. So there's a much lower barrier to entry. So this encourages more and more people to try things out, and that is what open source does to things. And then there's the added advantage of innovation and collaboration with the community pitching in to build things in a certain way. It helps a lot for a project to grow much more rapidly. And because there's a group of people not controlled by a central entity which is taking care of these things, you also get a lot of diverse perspective, and that is how technology evolves to serve the humanity better. And at the end of the day, it serves the end user better. There's also a very important factor of transparency and trust. So with most of the open source tools that we are going to talk about, they're fully open source. You can look at the code, you can look at the module made. So it allows you to it gives you the ability to fully inspect it and hold the creators accountable in a certain sense. And you can also ensure that things are being done in a more ethical way. And moreover, there's a lot of other benefits, which includes reducing vendor lock-in. So you're not particularly locked in with one particular vendor. So you can switch vendors if they try to get expensive. The development is much more sustainable in a way that not multiple companies are working on achieving the same output. So there are less duplicated development efforts, and you can start building from where someone has already reached. You can stand on the shoulders of giants and just build it forward or probably adapt it to your use case. And then you can also use it for socially benefiting projects because it's freely available with a better license. So looks like Gen AI boom that we had and open source supremacy is a winning theme. So now we're going to talk a little about why you should use the open source model that are available in Gen AI. So I think first and the biggest advantage is it allows you to quickly prototype things. So even if this is these AI models that we're going to discuss about, they might not be very well suited for your production workloads, but you can definitely try these out for quick prototyping. And what that means is like you get immediate access to pre-trained models. And alongside that, you get a lot of community support. So you can always reach out to the open source community that is maintaining that model and ask them for help around certain things. There are very, very clear instructions. There are there's like a multitude of people trying to do something very similar to what you are doing. So you get like a better starting point and you can quickly prototype things. And the other added advantage is that some of these open source models or tools in general, they play very well with other open source tools that you are already using. So that in itself is like a big advantage. Secondly, it's very cheap. Like most of the tools that we're going to look at today and the models that we're going to look at today, they're free to run. They're free to run. Some of them do not have like licenses for commercial usage. So please check that out. But yeah, these are free to run. So reduce development costs and not just in like running, but also in development. Because if, again, you're solving a problem, you reach out to the community, there might be people who might help you solve that problem. So reduce development costs and efforts. There are like broader licenses, there's community contributions in development. And the price difference, even when using these models for production workloads or in like a hosted solution, is very, very stark. So for example, if we take GPT-4o, it takes like for 1 million input tokens, it charges $5 and then $15 for 1 million output tokens in GPT-4o, while Mistral just like counts as like 15 cents for every million tokens, be it like input or output. So what you could do in GPT-4o with $20, you could, again, probably not reach that level of result, but yeah, you could do that, reach a certain level of accuracy with that, and probably even better for certain use cases in just 30 cents. And then there's like the biggest thing, which is privacy. You can run these things locally on your machine. So there is no data sharing with any third parties. You do not even need internet. So feels surreal, but yeah, that is possible. And then you get full control over the whole tech stack. You have access to the source code and the model weights. You can fine tune it. You can make changes to the source code or just like make sure that it is not doing anything that you don't want it to do. So yeah. So now we'll jump on to the meat of this talk. So we are going to talk about how we can use these models. And we're going to look at how some of the models that compete with the best in the class proprietary models that exist. We will also look at how you can run these models locally on your machine. We'll like have some demos around that. And then we'll also explore some hosted options for production workloads, which will be like again open source and also non-open source, but you can check these out for your use cases. And the fourth thing that we're going to cover today are we look at how we can generate text or code. And we are also looking at how we can generate images using text. We will look at how we can generate natural voices using text. And then we'll also look at how we can transcribe audio, which is like basically taking an audio file or a speech file or a video and convert, like extracting what the speaker is speaking out in that particular video. So let's get started with text generation. So these are few of the models that are like performing very well. These are all open source. Most of their versions are available with commercial licenses as well, but please like do check depending on your use case. So Llama is a large language model by Meta AI. In fact, that is the full form of Llama. It is large language model by Meta AI. So yeah, pretty self-explanatory. So the latest release from the Llama generation of models with the Llama 3, it outperformed Gemini, which is like Google's proprietary model, and Claude, which was Anthropic's proprietary model, in most of the available benchmarks at its time of release. Things are like slightly different now, but when Llama was launched, it was outperforming both Gemini and Claude in most of the available benchmarks. Mistral is again a French company, French startup, which was founded in April 2023, I believe. The initial team came from Google and Meta. Their first model, Mistral outperformed Llama 2 on all of the benchmarks that were available at that time. And now they recently, not recently, I think it's been like more than 6 months. Time passes very fast in like the Gen AI world. But yeah, one of their latest models is called Mixtral, this one. So Mixtral model outperforms GPT 3.5 Turbo on most of the benchmarks. But depending on your use case, you get like that much powerful model for free that you can run locally on your machine. And their code-shell models are more suited towards code generation. So if you're looking to build something like a GitHub Copilot or VS Code Copilot kind of a tool, you can look at code-shell models. The code-shell Mamba model is also available for your, it has like a much broader license that allows its commercial usage. Pi is a model by Microsoft, again, very powerful for certain varieties of tasks. Gemma is the same by Google. And then we have a lot of other open source models, which are very, very nicely suited for a lot of these tasks, including Falcon, Vicuna, Zephyr, Bloom, etc. So yeah, that's about these models. Let's see how we can run these locally. So we have two very nice options here. One is called LM Studio, which runs both on Mac and Windows. I believe it runs on Linux as well. So there's something that you can use if you need a good GUI. So let's look at how it looks like. So this is what LM Studio looks like. So if you have installed it, you'll land on the screen where you'll see a list of these models. So as of now, I have downloaded the Llama 3 8 billion parameter model. This is like an instruct model. It's more suited towards instructions and not chatting. But yeah, you can like, we will see what we can do with it. And then there's like a list. There's a plethora of models, and there's not an exhaustive list. You can search for any model here. I can see Llama, Mistral, 5.3, Falcon, Starcoder, Stable Element. And then you can like search for a lot of models or just like provide the Hugging Face repo URL. And then you can get started with these models. So I think I made a search for Gemma here, and I can see like 137 Gemma related models, different models suited for certain tasks. And then you can go to this AI chat interface, which is where you can chat with these models right away. So let us ask what is open source. All right, and it is responding back with the results. Now, the crazy part is like essentially we're running this completely locally. This data is not going anywhere. This is not, it does not require internet. I'm connected to the internet right now. But yeah, this is all running locally. You can see the results in plain text, markdown. Some of the models that support JSON outputs, you can see the results in JSON as well. And here on the right-hand side, there's like, you can set up the system prompt. You can configure the token length depending on how much like the context length the model supports. You can set it up. You can fine tune the temperature so that you get more creative answers, and you can configure whether to use GPU and whatnot. And apart from that, like the other amazing thing about this particular tool is that it also has like a local inference server. If you're running this and you have loaded a model, you can just start the server, and then you in your local development, you can make a call to your local host as it is described here. And you can just like use this model just like you would use OpenAI's APIs by hitting their APIs. So yeah, this is LM Studio. Definitely try this out. It's a pretty good tool. And they also have like a playground. So if you have multiple models downloaded, you can like add these models here and just type prompt in one of the sections, and you can compare the results of how these like different models are performing for a certain prompt. That's about LM Studio. Then there's this other tool called Ollama, which is Mac only. So it can be installed with Brew or any other, like you can just download it and install it on your Mac. And essentially at the end of the day, you just have to go to your terminal and just run Ollama full and the name of the model that you want to run. So we have pulled Mistral here, and then we can just do an Ollama run Mistral and then ask it anything. Why is the time 2? And then it will just respond back with information from the model that you are currently running. That is how Ollama runs. Olama also starts a server on the backend. So essentially, you can go to you can basically hit this particular URL. Olama runs the server on port 11434, and then we can ask it why is the sky blue. And if we pass the stream false, it will return the result in one shot. It'll take a little bit of time. I have a lot of things running on my Mac for the demo, but yeah, you see the whole result coming up in the response here. The result is returned as JSON. And if you want to use streaming capabilities in your application so that you want to show the output as it is generated by the AI model, that is also supported with Olama. So yeah, these are two really good tools that you can use for text generation locally on your machines. And not just on your laptops. There are apps that can run these open source models on your mobile devices as well. So there is this app on iOS called LLM Farm. I'm pretty certain there will be Android alternatives for this use case as well. So, but yeah, you can run these models on your local device. Now, imagine you have planned a sudden trip and you're visiting a new city and you just like got on a flight without having any information about the city. On that flight on your mobile devices, you can just read about the destination and figure out what to do there, all without Wi-Fi, all completely running locally without this data being shared with anyone else. So, or you can just learn about a concept, free knowledge about anything without the internet. The possibilities are limitless. The 5.3 mini model, which is like pretty good for such conversations, is just 2.2 GB. Mistral and Llama 3 are both less than 5 GB. The Mixtral model, which outperforms GPT 3.5, which is like the Chat GPT that we had 6 months back, the free version of Chat GPT that we had 6 months back, it outperforms GPT 3.5 Turbo on a lot of things. That is just 26 GB. And it feels like you downloaded a compressed internet locally that you can just talk to and ask about anything. So it's amazing. Just try these things out. So apart from that, there's like a few more resources that I want to point you to. So firstly, it's again Olama. So Olama supports like again a plethora of models. You can just go to the olama.com website and browse their library to see what all models are available. You can check any model, see how much memory it would require, how much RAM size it requires. Then you can choose the latest models or different models that you want to see and just like copy the command from here. Olama and Gemma 2. Paste it in your terminal. If you have Olama installed, you can talk to the Gemma 2 model then. So that's one of the things. LM Studio, I think we have already covered, but let's look at Grok. So Grok is it's again not a free service. It is a hosted service. Like it's a platform for running a lot of these models online. And what Grok has done is they've developed specialized hardware that works very, very well for the text-generated UI use cases. So as you can see, we have like the Llama 3 8D model selected here, so which is like the same model that we are running locally in my machine, and we asked it some questions around why is the sky blue. Just look at the speed of this. So this is like the fastest inference that is available. I just push command enter, and that's it. We have the whole answer there. So if you're developing a solution where the speed of generation or the latency matters a lot to you, or if you want to generate live commentary on a video that is going on, or like an audio that you want to live transcribe, you can use something like Grok to host your production workload. It is not very expensive again, because like the cost that you're paying to Grok is mostly for running the platform, as most of these models are essentially free. So yeah, give this a go. I think the other thing is, like, I think one thing that becomes very, very important when choosing which model to use is figuring out which model is the best for your use case. And there are like certain benchmarks that are available that you can see. So I have this Salesforce. Salesforce recently did a study, and they benchmarked a lot of models for CRMs. So they had like different areas, whether they want to see the benchmarks of like sales or service, what type of operations that you want to do, whether you want to generate new content or whether you want to summarize existing content. And then there's like use cases of like you want it for sales call summary, sales email generation. and whatnot. And they've compared a lot of these models, all proprietary as well as open source model. I don't know why it's reloading, but yeah. So you can see what the cost is, speed is, how like trustworthy these models appear, how permissive their licenses are, and then you can judge them on different things, on instruction following, completeness, conciseness, factuality, and whatnot. It's like a very comprehensive report, definitely like worth geeking out on. So there's one thing, and if you're like specifically interested in open source models and these the specific benchmarks using which these models are tested on, so you can check this. Hugging Face has like an open LLM leaderboard where they have these different benchmarks. Like for example, this is like the MTB leaderboard. So if you check this out, it'll list which model performs in what order, and you can run these benchmarks on Hugging Face in like. You do not have to just look at the reports. You can just like perform those actions and see how well these models are performing. And in terms of other playgrounds, I think one thing that I like a lot is like Versal's AI playground. So what you can do here is like I have, as you can see here, I have like added a lot of these models there. Like there's, you can add anything. Like I think there's OpenAI here, then there's like Meta's, one of Meta's models, which one have you? Yeah, so we have GPT-4, we have Llama 370B, we have Llama 270B, GPT 3.5 Turbo, and I think there's GPT 3.5 Turbo again. So probably let's change this to like, I don't think I can use a Pro model, but yeah, let's do Gemini. And if I want to compare the outputs of all of these models right away, so I can just write well open source, ask it a question, and it'll respond back from all of these LLMs. So you can see the speed, you can see the quality of results that you're getting. You can fine tune your prompts in a way that they work well on certain models. Yeah, this is also a very important resource that you can check out. Now let's move on to image generation. So, image generation, again, like when DALL-E came out, it felt it was doing impossible things. Now there are a lot of models that are performing much better than DALL-E. So the biggest variety of models that are most widely used and they have like a commercial license is Stable Diffusion. So they come from a company called Stability.ai, and they're pretty good at image generation. And they have these plethora of models, 1.4, 1.5, goes up to 3, then XL Turbo, and then there's like hundreds of other fine-tuned variations, again, depending on the task that you want to perform. Then there's Deep Flight, which is also pretty good. It is very, very useful if you want to generate realistic photos, like high photorealism, and you wanted to understand, like, give more emphasis or like more priority to what you are asking it to generate. So it has like a much better language understanding, and it can generate nice text inside of images, which is not the case with most of the existing image generation models. If you ask it to generate a t-shirt with like GeekConf written on it, it will generate some garbled text. But yeah, DeepFloyd does a very good job with that. And then there's like highly specialized models like Animagine XL is for anime generation. It gives a lot of priority to the sequence in which you are providing the prompts. And on the basis of that, it will generate like a very relevant image. Then there are like, these are not models, these are just techniques. So LoRa is a technique to fine tune a model to reduce the number of training parameters. So what we are essentially doing is rather than making a model, like rather than having a model that is capable of doing a lot of things, what we do is we reduce the understanding of a model so that it performs very well for only a certain task. So this also vastly reduces the storage requirements of a model because it's adapted to perform only a certain task. Let's say you want to generate only slides, or if you want to generate only kids' comic books. So then you can use LoRa-based techniques to use that model, fine-tune that model so that it like becomes smaller and it's like more efficient at just that task. And this not like LoRa is a technique of fine-tuning. It just does not work with just the image models. It also works with the text generation models that we saw earlier. And then there's like control links, which are just like, think of it as a control layer on top of a model that adds the ability to control certain characteristics of a model. So let me explain it with an example. So if if you have a model that generates images, like full body images of humans in as a portrait image, and then you can use control nets, for example, to provide inputs so that these things you can control, let's say, the pose. If you want all the images that are generated to like be doing a wave, so or like have their right hand raised, so those kind of things and adding those control and capabilities can be done with control nets. Now, the amount of models that are available for image to text generation are just like too many. There are 18,000 plus text to image models just on Hugging Face alone. Hugging Face is a repository where you can try these models out. So there's like more than 18,000 models there. So whenever you're attempting to solve a problem in the text to image generation space, see what exists and probably then try to build on it or like try to fine tune those models. So again, running these locally. So there are two very, very nice options available here. So this is like, again, works on any machine, Linux, Windows, Mac. So it's called Automatic 1111 Stable Diffusion WebUI. So this is their repository. So you can just go here, clone from here. They have set up instructions for all of these, all types of OSs. And this is how it looks like at the end of the day. So I have installed the stable diffusion model here. Installing a model is as easy as downloading a file and placing it in a folder and clicking this refresh button. So I have downloaded stable diffusion here. Let's ask it to generate an image. We'll ask it to a cute puppy robot dancing in the rain. Let's see what it generates. I'm not providing any negative prompts to probably generate something like it. So all of these things are running in my machine. I'm like currently on like a MacBook M2 Pro. Not the Max version. So there's not a very big GPU. And we still have the LM Studio running. We still have Olama running in the background as well. And we have the stable diffusion now also loaded. So these are like very, very light. They're not lightweight models, but like the machines nowadays are so capable that they can do certain things. So that's the image that we get. I think it's still generating it, probably beautifies it a bit more. So yeah, we see rain. We have like a cute robot. Doesn't look like a puppy, but yeah, it's pretty good. It's pretty good. All running locally. It does not need the internet. It's amazing. So, and then you can do, this is not the only thing that you can do in this stable diffusion WebUI. So what you will see here, they have like a lot of options here. You like eventually get used to it. So if I click on this, so this will send this image to the image to image tab. And here, let's say I want to just, if I want to inpaint something inside this image. So inpaint is basically if I want to change this particular area, I can generate this mask by my mouse, and then I can like give it certain instructions. You can replace this head with like a human head, and it will do that. It will try to do that again, like depending on its capability. You can do all of these things. There's a lot of configuration that you can do here. Even like I have not explored this tool to the best of like its powers, but you can go to settings. You can check out the extensions. The extensions like essentially they have like a list of extensions that are available here. So if you click, click on load all, you load from and give it the URL, which is like by default present here. But you can load from different registries as well. But this is like their officially maintained registry. And let's say you want to generate something for example, we look for text to. So there's like a model for text to video. So if you want that ability inside of the stable diffusion web UI, you can just go from here, install any of these models that you want to try out, and just give it a try. You'll start seeing it. You can switch to that model. The tabs will change accordingly, and then you can just perform what you want to do with this. What else? I think there's one more very amazing tool that we should look at, and that is Comfy UI. So essentially, when you are solving a problem in the text to image generation space, you are essentially a lot of times you're not just, I think lights are, it's getting darker outside. Let me turn on some lights. So a lot of time what happens is that you just don't want to perform one thing. You want to, let's say, generate an image and then upscale it, then probably have you sitting next to a celebrity and get their photo in. So there's like a lot of processes involved, and that is where like this comfy UI comes in very handy. So looks like this. It's like an interface where you can add these things. Hang on, let me get to a perfect zoom level. So it's an interface that you can add nodes to. All of these things are nodes. So depending on what all nodes you have installed, you can add nodes. You can take the output of one and put it in the input of other, and then make these connections and create your whole workflows. So essentially, this workflow that we are seeing here, it's like a workflow which is just an image generation workflow using Stable Diffusion. So we have this prompt here. You can change this prompt. All of these nodes are interactive. You can change the properties of how big you want the image to be. And then you can click on Q prompt. And that will queue the prompt. And you can see that now it is running this process defined by this like green box here. So it also allows you to understand the internals of what is happening inside the whole process in your whole image generation workflow. So let's give it a few seconds. I think the image should appear here. And then you can take the output of this particular image that we are getting from here and then also provide it to another node if you want to connect it to another node and just see the outputs of that using all of your workflows. So I think the default prompt here was beautiful scenery, nature, glass bottle, landscape, purple, galaxy bottle. And this is what we got. It was pretty nice. Again, all working locally. The amazing part about this comfy UI is that you can save this workflow as a JSON. And if you have created a workflow and you want to share it, you can just send it over to your friend and they can open comfy UI. They can load that JSON and they will have the same workflow with them. And let's say you are using a lot of external nodes or like custom nodes in your workflow. So you can just click on this manager button here and you can just click on install missing nodes and you'll find all the nodes that are being used in the workflow and that are not installed in your comfy UI and automatically install them. Similarly, in this comfy UI manager, you can find a model manager where you find 305 external models apparently. But yeah, you can check out all the models here. So this includes everything like Stable Diffusion and a lot of other very, very specialized models for certain tasks. So yeah, moving ahead. So in terms of the resources and demos there, I think we've already covered Stable Diffusion, Web UI, and Comfy UI. But there's like this amazing website called Replicate. Again, it is not free, but it'll give you an idea of what all models exist. So this is like, we are on their Explore page right now, and you will see that they have categorized the models depending on use cases. So if you want to generate images, restore images, upscale, there's like text-related models here as well if you want to transcribe speech and whatnot. So let's take a look at this model. I think I have it open. So this is a model which just takes in an input image, and then it also takes like a URL to an external video, and then it just takes that input image and generates something like this. So basically, we are making that person do certain expressions on their faces that were present in the video. So it's amazing. The other thing that we talked about was like the JSON that we were getting out of Comfy UI. So there are models available here on Replicate. So you can just provide that JSON to an API, and then you can get the same results. So we can just like copy the JSON that we are exporting from Comfy UI, send that over an API call, and we can use this whole Comfy UI workflow just using an API call. Apart from that, there's like this company Stability UI, Stability.ai, which is the creators of Stable Diffusion. They have they have like a hosted solution for all of their models. It is very cheap. So definitely do check them out. Their models, I think for like $10, you might be able to generate 10,000 images. So it's pretty good, like very cheap and very, very reasonably priced open source model. And then there is Civet AI. I have some interesting bits from here. So basically, this is also a community-driven platform where people are training their fine-tuned models. So for example, these models are very, very specific sometimes. So for example, this model is just like generates texture with great detail. So if you want to use this, you can download this model from here. They have instructions on how you can use all of these models in the Stable Diffusion web UI as well as in Comfy UI as well. You can try this out. This this example, for example, is like a model that generates very detailed texture. But if you want to do something very specific, that if you want to generate anime images where one character is carrying another character, that is also available here. So if you want to generate anime images of characters doing one-arm handstand, there's a model for that. So definitely check out Civit AI. There's another funny model that you're seeing. So you can give it any image and then you get a slider in Comfy UI using which you can choose the level of jewelry you want that model to wear. So this is 0, this is 1, this is 2, and it goes up to anything. And you keep on increasing the amount of jewelry that the person in the image is wearing. So yeah, Civit AI is like, again, a very nice resource to check out to see if there is something available for the kind of things that you are planning to do. Now let's talk about speech generation. So natural speech generation is one of those things that is not taken up a lot in like the open source community, but there's like, again, there are some very good projects here. So there's Rally by Microsoft. It is very good for quick personalized speech. So you just need to give it like 3 seconds of your audio and then the text to generate the audio for, and it can generate the rest of the audio just with 3 seconds of your audio, which is pretty good, which is fantastic. Then there's Cocky TTS, which is like a text-to-speech engine. It's been like, I think it predates GPT. And it's a project that's been around for a very long time. So the amazing part about this is that Cocky TTS has pre-trained models in more than 1,100 languages. So if you want to generate speech in Spanish or any other languages, there's like 1,100 models available that you can use. And there's like an option to also fine tune so that it speaks in your voice. Then there's Tortoise TTS, which is also pretty good. It was named Tortoise because it was very slow when it was like launched, but I think like it was launched quite a time back. So with the recent hardware, it works very well. People have configured it to run almost real time, very realistically with under 500 milliseconds of latency. So what that means is, let's say you're creating something where a person is speaking to an AI and you want to respond with an AI, naturally generated AI voice, Tortoise TTS is something that you can use, but you need like a good hardware for that. So in terms of the resources, I think Valley is, there's like lots of implementations of Valley available in different languages, mostly Python backed. So you can try that out. OpenAI has their own TTS models, again, not open source, but those are like, again, perform very, very well, but they have it in 6 voices only. 11 Labs is like one of the leading players here. They can generate AI audio, they can do text to speech, speech to text, dubbing, text to SFX, there's voice cloning. You can create models of your own voice and other people can use it. You can even get paid to create your voice clones if it gets used. You can choose the language, you can choose dialect. So this platform is pretty good. It is like fairly expensive as well. They have their own proprietary models, not open source, but you can like probably get prototyping with Valley or Cocky or Tortoise, and probably for production workloads, you can use something like 11 Labs. Moving on to the last section of this. So this is GenAI models for speech to text. So basically we want to listen to speech, make the AI listen to speech and get the text out of it. So Whisper by OpenAI is one of those models that they open source. So it can like perform speech to text in 108 languages. It like splits your audio into 30-second chunks and then generates a spectrogram out of it. And then there's like a lot of processing that happens. And then there's like special tokens are inserted into that processing workflow that can help with language identification, phrase level timestamps, and like just detecting certain utterances of when a person is speaking a certain word. And then multilingual speech transcription is also present, which means like if there's like 2 speakers, if in your audio file there are 2 speakers speaking in 2 different languages, it can take that as well, which is fantastic. Then there's like Wave2Vec, which is open source again. This comes by Menahi. This has better support for languages and dialects with lesser training data is available. So it again works on a fairly different principle, chunks the audio into like 25 millisecond chunks and tries to understand each and every utterance. And that is how it performs things. Then there's Deep Speech, which is by Mozilla, the company that makes Firefox. It only supports detecting speech out of text out of speech for only up to 10 seconds. So this is very, very nicely suited for applications where you just need to process some commands, or if the user is giving a command in a very short time and you just need to understand that. So yeah, these are some of the options that we have available here. So setting up Whisper is fairly simple. It's just mostly setting up Python and installing Whisper and then downloading the models for the languages that you wish to support. So that is pretty much about this part. So now as we're concluding our talk, I think there's three things to remember here. So I think because there's like a plethora of these resources and the open source community is like working so hard to create all these models and make it available to all of us for like essentially free. So I think the first thing that you need to do is when you are solving a problem, try to find the best model for your use case, because there might have a lot of efforts gone into doing or achieving certain results that you want to achieve. So I think find the best model for your use case. There is probably something that is doing something very similar to what you wanted to do. And then you can build up on top of it. Secondly, just make sure that these models have the license for commercial usage. Because like if you start building on a model and that is not available for commercial usage, you cannot use it for commercial usage. But yeah, running these locally, developing your apps locally for you that you're not selling is completely fine. And then last but not the least, like figure out a way to contribute back to the community, help other people, answer these things. I myself do not know these technologies well enough that I can contribute by code. But yeah, just like talk about it, make people aware, let them know how they can benefit from these technologies. And I think that is all. So thank you everyone for this opportunity. I am the Rajat Kapoor on Twitter. You can find me here on Twitter. I think that is the place that I like spend a lot of time on. So it's like there's the highest probability that I'll read your messages there and respond back definitely. So I might be late, but I'll definitely respond back. But yeah, so if there are any questions, I'm happy to take them up.
Thank you, Rajat. The talk was wholesome. It covered pretty much all the questions I have. I have one last question. So, what impact do you foresee on the privacy and security with the increasing use of, Gen AI in open source projects?
I think it's going to have a huge impact. There is no two ways to look at it. I think we are already seeing a lot of impact. So there's this very amazing video that Microsoft shared in one of their keynotes earlier this year. And that was about like a project called Project Recall, where they showed that they'll have an application running on your Windows machine that will keep track of all the emails that you have read, of all the photos that you have visited, of all the websites that you have browsed. And you can ask it any question and it'll help you remember that. And it goes even further. It can like help you play games and just like looking at the screen all the time. So, but like it gets hard to trust these external entities. So I am seeing like open source companies and like a lot of people making efforts in that direction and making that a reality. So imagine if all of this is happening on your machine locally without the need of internet. That is going to be a crazy experience. So I think like the possibilities of this are endless. It just like I think what I want from this talk is like people come up with ideas and build some interesting solutions with it, because the barrier to entry is very low and the opportunities that it opens up is limitless.
Cool. That answers my question. Thank you so much, Rajat, for amazing demos and the talk. Thank you so much for being part of the GeekConf. We'll see you next time.
Thank you. Thank you, Smile. Bye.
Moving on to the last and the final segment. Last but not the least, the final segment of today, the remote day of GeekConf. We have a very good friend of mine, Shayan, who is a founding engineer in a company called ZDuty. He'll talk about how we can create some amazing design systems. So over to you, Shayan, and you can enlighten us with your knowledge.
Hey everyone, I'm Shayan. Thank you, Smile, for the great introduction. And yeah, I'm going to talk about a secret sauce, as I call it, about great design libraries. That's what we're going to get into. So, shall we dive right into it? All right, then let's dive right into it. So, I'm Menahi Shayan. I'm a founding engineer at ZenDuty, and I also lead the front-end engineering team. ZenDuty is an end-to-end incident management platform where we help you minimize your downtime and meet your SLAs. We deal with all of your on-call management, scheduling, and integrate with all of your monitoring services to give you a great incident management experience. So what I'm going to share with you today is a secret sauce, as I over dramatically mentioned, about great design libraries. But for you to truly understand how that's valid and why that makes sense, let's take a look at a few years back. Okay, let's look at what design libraries looked like back in the day, and what made them obsolete, and what made room for newer and greater design libraries to come in. So I'm sure a lot of you would have remembered that back in the day, there weren't as many options for design libraries as we have today. We had some of the two go-tos, maybe Bootstrap, Material UI, maybe a few other ones as well. And in their initial phases, all right, I'm sure a lot of you may have worked with these. They were interesting to work with. They solved a lot of problems for us back in the day. So but now we've got so many more. We've got Radix UI, we've got Headless UI, we've got Semantic, we've got Tailwind, we've got a new version of Material UI, MUI 3, that takes things above and beyond with the component libraries they provide. And even GeekyAnts is very own BlueStack UI, and all of these things. Now, so what made room for all of these new UIs to come in and sort of exponentially drive a growing trend, especially on Twitter and other social media, where a lot of people advise you to prefer these systems rather than the OGs that actually walked so that these systems could run. So there's no doubt that the previous UIs, Material and Bootstrap, they were great, and they still are. Okay, with the newer versions, they're still making great improvements. But let's look at the trend. All right, I've got data to show a little more light on this. So Material UI and Bootstrap were incredibly popular on search trends. So this is a Google search trend from a few years ago. I'm sure when a lot of people were initially getting into the front end development phase with the JavaScript slowly taking over and whatnot, they were incredibly popular frameworks. But as time moved on, if you look at the trend, Tailwind and things like Radix UI and ShatCN completely blew those two out of the competition. And you can clearly see that there is a sort of decline in the older frameworks. And what I'm talking about is this little part in the end here, where there was exponential growth over there and a sort of a slight decline over there. So what's going on here? Like, why is this trend changing? So to answer this, let's sort of like cut down deep into this and let's analyze what makes new libraries preferable. It's very simple. It's very simple, as it sort of comes down to how other developers sort of integrate, install, and adapt your new library. To show you an example, let's look at what it felt like working with Material UI in the old days. I'm sure a lot of you would looking back at this and be like, oh yeah, this was the good stuff in the old days. This is where a lot of people started their coding journey. This is the sort of boilerplate that you would need to write to create a simple hello world button. You import the ready-made out-of-the-box button, make it primary, and that's it. You've got hello world. As simple as that. This is really good, right? Really good for people getting started with web development, and really good for people to get their web pages out as soon as possible with minimal effort. But this isn't everything. Let's say for most enterprise requirements, right, or larger projects, you would want to customize these things. Let's say something as simple as changing the background with a gradient, or maybe just getting rid of this uppercase text because this button is really screaming at me. Okay, like I know I'm being welcome, but can you not scream? How do I make this lowercase or at least capitalize it? Let me try this. Maybe I add a class name, linear gradient, and maybe I change the style to the text transform, capitalize. Nope, it's not working. Let's figure out why it's not working. Let me go ahead, inspect this, and see what's going on under the hood. So if I actually go ahead and inspect this, you realize that so first of all, the classes have been hashed over here, so you can't actually see the exact class names being applied. But if you look into this, there's inside this button, you have two span elements. So even though if I were to apply a text transform on the parent or even a linear gradient on the parent, you can see that the span below probably has some other attributes there that is overriding that text transform over there. You also have it's very likely that some of the other class names over here and the parent button, the J57, J what and whatnot, 175 and all of these things are likely taking higher precedence of specificity, which is why your customizations are not being applied. Now this is not very convenient because if I was someone who wants to customize my UI and like adapt it to my requirements, I would ideally like it to be this simple where I could just apply any class name that I want and it should respect that, right? Yeah. So how exactly did people solve this problem back in the day, at least for MUI v1? So one solution was there was something called the classes prop where you could individually specify what child element to apply what classes to. So maybe for the root element, you could apply a specific gradient, and for the label, you could apply a text transform. But you would have to get into these, inspect, figure out how many elements are actually in there, and apply it specifically to those elements. It may be not much of a problem for something as simple as a button, but think about more complex layouts like drop downs, selects, multi selects, even. What if you want to customize those to fit the look and feel of your brand or your website? That's very quickly going to get very tedious. In fact, this wasn't the only way. There were a few other approaches to actually customizing and overriding these styles. Like there was something with internal states, right? So if you had to maybe handle a disabled state or a hover state or a focus state, that approach was different. So you had to specify it this way and then apply the overrides there. And sometimes even that doesn't work because of certain specificity issues where they had another approach where you had to work with something called a JSS nested plugin to increase the specificity. All of that is starting to become really tedious. Now, even despite all of this, people were having a lot of issues, like something as simple as inline styles. You would expect that hard coding inline styles would be the simplest way to enforce that this your particular style that you want is being applied. But for some components, even inline styles weren't being respected. That's how um, that's how much of an inconvenience it was to adapt these UIs to your brand and your requirements. And even the answer for this particular Stack Overflow question is basically dealing with increasing specificity and like CSS gymnastics per se. So, leaving the style customizations aside, let's look at some of the dialogue components that were there in the early days of Material UI. So this seems all right, easy to get started with. But if you want to build complex layouts, maybe complex dialogue arrangements, and really gain complete control over this specific UI element, these props are not enough to allow that, right? So there was limited functional customization. That was MUI v1, and Bootstrap was also quite similar. So if you're getting started, you could just create a few buttons like this. You just use BTN, primary, success, and whatnot, and you're off to the races. Very pretty looking buttons. But then, what was the problem? Every button on every popular page started looking exactly the same. There was there was really a lack of identity in a lot of these pages, which is why people decided we want to customize these. And customization sort of looked like this. Yeah. When you start writing important in every single attribute in your class name, you realize that something's wrong, right? Reading your code was going, peer reviews were going to look like this. Okay, so not the best experience. So this translates to some inconveniences that we can pen down specifically. That's overriding styles to retrofit your brand, accessing control, modifying the control over the components that you have, the functional control, as in elements, wanting elements to behave a little differently, or maybe custom flows that you want to implement with these components that were sort of not possible because of how restricted the API was for functionality. There was also a huge code bloating issue, especially with Bootstrap, because Bootstrap was bundling every single class name that it had, unlike Tailwind, where Tailwind removes the unused items. And sometimes people were wrestling with Bootstrap and their own CSS, where one of them was overriding the other, and the other one was overriding the Bootstrap one, and whatnot. It was a huge Game of Thrones scenario over there. So that sort of explains that it's understandable that something else came along the way that that sort of grew exponentially, that was more preferred because it likely solved a lot of these problems, right? Because for something to take over, it has to address the inconveniences that were previously faced. Of course, I'm not saying that Material and Bootstrap are currently bad. They've improved a lot with the newer versions, and they're still good alternatives. But let's look at why this trend happened and how did modern libraries actually deal with this problem? How did they fix this? So the data that I specifically pulled was pertaining to Radix and Shayan that are two incredibly popular design libraries on GitHub as well as a lot of social media platforms. So let's dive deep into this problem while taking specific examples from these popular modern libraries. So for one, it offered unstyled components, right? So you didn't have to deal with out-of-the-box Material UI buttons that had specific hard-coded styles that you couldn't get control to override and retrofit to your brand. So it shipped out of the box with zero styles baked in per se, where you had complete control to sort of modify what styles you want to keep and what styles you want to remove. Even ShatCN that most people use today, you have complete control to manually install those elements and completely change the styles that they've got. Another popular, another good factor that helped modern libraries here is incremental adoption. So rather than bundling the entire design system like Material, Bootstrap, or Radix, what a lot of design systems today are doing is they're they're providing you only a single component in each package. So if you're working with Radix per se, you would likely import maybe Radix slash dialog or maybe Radix slash alert, right? So you're only importing a single element. So you're only installing what you need. These elements are broken down into individual packages, and this reduces clutter, right? This reduces clutter, reduces bloating as well, keeps your bundle sizes down. So that's been incredibly helpful, and that's incredibly preferred by a lot of developers today, where you install only what you need. Another big one has been open primitives. So rather than providing an abstracted, encapsulated model or a dialogue saying, this is how it works, these are the 4 props that you can control, and just work with it. What design libraries today are doing is they're providing each primitive separately. They might provide the root element separate, the content separate, the trigger separate. All of these items are imported separately, and the developer has control over how they want to use these elements, or even whether or not they actually want to use these elements. So that sort of allows for a customization that we had never seen before. Because let's face it, if you want a different UI to sort of adapt to your brand, you will eventually need to break apart from the initial restrictions of the design system, because design requirements can keep growing. So which is why open primitives really allows it allows you to design a certain library, import a certain library, and then design it to suit your needs. And finally, uncontrolled components. So in the initial, the older components, right? So all of the states were managed internally. Let's say the opening and closing of dialogues, the functionality of models, the dismissing logic, these things were all baked in internally to the component, and you did not have much control over what happens when you click on these. Let's say you want to submit a model, it the closed state would probably be baked in, right? Or maybe you want to dismiss it. You want to dismiss by clicking the backdrop. That state would be baked in. So if you want to run certain actions while that's closing or while the internal state is changing, a lot of people did not have access to do that. So component libraries these days are providing both controlled and uncontrolled components out of the box. So developers are free to choose what they would prefer. So I'll give you one example to sort of illustrate all of this incredibly well. Look at this one example of a Radix accordion. All right. So first of all, it's completely unstyled. These are all vanilla components that ship out of the box, and you can apply whatever styles you want to it. These are also installed incrementally. I did not have to install all of Radix's components just to get this one accordion running. I only had to install the one component that I needed. So that really helps me reduce the bloatware that I'm shipping. Another one was open primitives. So rather than Radix giving me a single accordion with just a children element or like an array that I could pass, I have complete declarative control over how to define my items, my content, my trigger, all of these things. And the best part, it's completely uncontrolled as well. It can be controlled and uncontrolled. So this is controlled by default. But if I want, I clearly see that the IntelliSense over here shows me there's an open prop and there's an on open change prop as well that I can pass, and I could control the state from outside. So I've got control to manage the functionality here. That's great. That's great. That really sort of explains why this trend has sort of shifted these days. But that's good. That's good in itself, right? But what is the so all of these things together sort of encompass one single theme, right? All of the points that all of the improvements. The single biggest problem that these libraries are solving is improving the developer experience. That alone was enough to completely shift the trend and cause exponential growth for some of our modern design libraries that we use today. And that is what I believe is a secret sauce to great design libraries. That's great. But what do I do about this? You're probably sitting here listening to this talk and like, okay, fine, he took us to a long journey of what happened and what's better now. But what is my key takeaway? What am I getting out of this? Let me boil it down for you. The actionable takeaways that you can get from looking at the journey of from looking at the evolution of the popular design libraries back then as well as today. Of course, a lot of us, when we start developing really large projects, right, either enterprise projects or hobby projects, we often feel that we'd like to build a great design library, right? A lot of our hobby projects and as well as enterprise projects start off with generic libraries that are already out there: Material, Bootstrap, Andy, and Design, and whatnot. But eventually, there is this growing feeling that you might want to build your super fancy design system. And a lot of people, either intentionally or unintentionally, start doing this because you start boxing up your components into things that can be reused, or code that can be reused, or sort of larger abstractions of existing design libraries that you can use in other places to suit your project's needs. And we at Zenity had the same problem as well. So we initially started off with ant design, and we decided that it's time we build our own design system. So we started building our initial V1, where we just started boxing up existing components and building some of our own, for specifically for the purposes of our project. We called it Zen Design. Um, Interesting choice of a name, I would say. I came up with that. Not very great, but that was our initial version. But that did not work out that well, which is why after an immense amount of planning and research, we ended up with a brand new design system, Enso, which is currently in alpha. So through this journey, what have we learned, and what can I share with you so that you can take these actionable insights from past experience to build your great design library. The first takeaway: consistency and standardization. So look at this particular example of a certain alert dialog. All right. So you can see that I'm defining, so I define the primitives as a root first, and then I define a trigger, and then a content, and then a title, and then a description and whatnot. So this is one definition, but true consistency would mean that even if I'm trying to create primitives for a completely different element, right? I would assume that the tree structure is the same. The tree structure of the children and the definition of these elements would be more or less the same. And if I look at Radix's React dialog, that is true. So between the alert dialog and the React dialog, the structure is almost entirely the same. They've got the same root, the same trigger, the content, the title, the description, and they've even got the same, almost the same props, as in the control state, the open and on open chain states and whatnot. So yeah, so let's say I've got a dialog here. So not even for the same component, even for different components. Okay, so if I compare this to a popover element here, okay, so both of these elements can be controlled or uncontrolled, right? They could have open states and open chain states. So I would expect that if I learn the states, the API control, a control API for one element, I would expect to be able to reuse that knowledge for other elements as well. And that does hold true. So both of these, the dialog element and the popover element, support the same open state and the on open chain state. There is consistency in terms of the definition of the tree structure as well as the API for control, despite them being completely different components, by the way. So that's one. Another one is semantics. All right. So semantics is often overlooked, but is incredibly important if you want your design library to scale. So adhering to semantic HTML is a big one. Now, a lot of people looking at this would go like, I've got X years of front-end experience. Of course, I'd never make a mistake of not adhering to semantics. But then you look at the code and then you realize, is this a button? Is this a link? What is this? They're like, no, trust me, this is a button. This is a button. Is it? This may be a bit rare, okay, but more realistically, a lot of people may end up creating buttons that link to something else, or maybe open a new tab or navigate to a different part of your app. Either knowingly or unknowingly, you end up having buttons redirect to URLs, which is technically bad semantics. You should be using the A tag for those things and buttons for other actions that you perform. So you'd be surprised how many elements that you think are links are actually buttons under the hood, or maybe you think are buttons are links under the hood and whatnot. Yeah. Another one is adhering to area. The area is for accessibility of internet websites. So you need to realize that not everyone is as privileged with the same abilities that we are, and it's important to be inclusive while building websites. And that starts with a fully accessible design system. Now, another big takeaway that I want to dive into is differentiating components by purpose. So let's say you've got two elements that seem almost similar. Look at this, for example. You've got an alert dialog element here, and you've got a dialog element. Now, these two elements have almost the same definition, right? They've got a similar structure, and they seem to be doing almost the same thing. But you need to realize that these two elements have completely different purpose. They were built for a different thing. That's why there are two of them. So this is what they would look like. One of them is an alert dialog, and one of them is a regular dialog for other operations, right? So this is they behave differently. One of them is dismissible from the backdrop, one of them is not, right? One of them needs you to select one or two of the one or two of the available actions, and only displays text, a title and a subtitle. The other one has a fully customizable content layout inside, is dismissible, and does not need you to select a specific button for it to work. So they're built for different purposes. That's why there are two of them. Another big one is to allow for modularity. So this is a little complicated. Okay, let's look at a certain example. So look at this picker element, popover code that I've defined here. Okay, I'm trying to build a little picker, and I'm importing popover primitives. And I'm defining my popover element this way because I want to pass a certain state, and I want to have a trigger and like a certain bunch of list elements and whatnot inside my popover. Now, I'm going to create another popover element. Okay, it's a different design system. It looks a little something like this, where I have the popover, I just define the parent, and inside this, I just have the content as the body. And I have maybe 4 or 5 props, at max, maybe 6 or 7 props. And all I do is just work with the available props that I have to build the entire popover. Which one do you guys like? So I'm going to give you maybe 5 to 10 seconds. Just take a moment and look at these two code definitions, these two syntaxes. I mean, I realize they're doing slightly different things, but which syntax would you personally prefer, A or B? So if you've thought long enough about this, you may at first pick one A or B, but eventually you'll realize that there is no straight answer for this, right? B is better in a certain way because B allows you to ship code faster. You write lesser code, right? This looks much nicer. It's easier to just get it out of the box, minimal setup, and just get it up and running, a smaller learning curve, all of that stuff. But B can be incredibly restrictive, right? Think about what if you want to change the customize the title, maybe add an extra button in it. What if you want to change the way it's triggered, maybe change the way you render the content, add a few extra buttons in there, maybe change the backdrop. All of these things are likely not possible with this sort of API definition. So initially it may be fine for you, but you will not be able to adjust this to suit your future needs. So you may install this package. Let's say someone else who's using your design library installs this package. It seems good, seems peachy initially, gets it out of the box and ships it. But maybe 5 or 6 years down the line, that person's design requirements are not going to stay the same. The people that use your design library are not going to be able to fit all of their requirements into this concise, restrictive prop structure. And what's going to happen is eventually they'll feel like this is not a great design library, and they'll feel like, yeah, this needs to be replaced. This is not going to work for us. And they'll just replace it. And there goes the decline of your brand new design library. So that could be a problem. But if you look at A, right? A gives you complete freedom to customize that layout. You can import the primitives however you want. You could change the primitives. You don't even have to use popover primitives inside. I'm using a command primitive, an input primitive, all of these things. It gives you full flexibility, full freedom, and this is sustainable long term. So initially, if I want command over here, I would just have that. And after which, if I want to replace it with something else, I want to build a different element and put it in there, I can do that. I've got complete freedom, and this is going to sustain long term because 4 or 5 years down the line, I have full flexibility to change this. But there is a problem with A as well. You can't really enforce your design constraints. If you think about this. So if you give users full control to customize the design system as much as they want, completely change the styles, completely change the functionality, change the structure of the way you define your props, change the behavior, all of that stuff, is it really the same design system that you made? It's like the ship of Theseus problem, if people are familiar with that. So there's sort of an ideological problem here. Do you go with if you're building your design system, do you go with route A or route B, right? So do you allow customization for the user as much as they would like, or do you restrict it to enforce your design principles? So principle A would be something mostly modular where you have complete access to customize as much as you would like. But the principle B would be something that's opinionated, where you put your foot down on a certain design and be like, no, this is how it needs to be, and there is a reason for that. So most design systems either lean one way or the other. They would either be really modular or they would be really opinionated. So you're going to need to decide which one you're going to go with. And if you're as indecisive as I am, just do both. Yeah. So when we were building our design system, and so we ended up providing both primitives and abstracted components. So it clearly shows that I'm very indecisive. But what happened is most use cases would just require simple boilerplate that you could just import and get started out of the box without writing too much code. But there are only few instances where, let's say maybe about 10 to 20%, less than 20 actually, where you would actually need to import the primitives and change it as per requirements that don't fit in with the abstraction that you've made. So it's a good idea to provide both, so that, but design your abstracted components in such a way that they suit at least 80 to 90% of people's needs, but they also have primitives if they need it. Another one would be separating the feature from the component. So a lot of the times what happens is there are some components that aren't initially planned in the beginning, right? You just start building a specific feature, a requirement that has come in, and say, okay, I need a time zone picker, and I'm probably going to use it in 20 different places. So might as well move this into its own component. I start building a time zone picker here, okay, and realize, okay, yeah, this is a good component. Let me add it to the list of my design libraries components. But then you realize not everyone needs a time zone picker, like a specific picker that just does time zone. You could maybe generalize this a little more so people would be more inclined to use this. So just make a picker, right, with more generalized component props that accepts more elements, is a little more customizable, right? This is something that more people would likely use than a specifically designed picker for a specific purpose. Yeah, another one would be purpose-driven component design, right? So if you're paying attention to the transition between these takeaways, you'll realize that it's not this or that. It's not black or white. There's always a sort of gray area, or there's sort of a percentage trade-off that you'd have to make. It's sort of a spectrum, right? So purpose-driven component design is basically, rather than just making components that are as generic as they can get, like three different pickers that accept all of the same props and like do exactly the same thing, but with slightly different styles, that doesn't exactly make a lot of sense, right? So ideally, the component set in the beginning should be planned out for specific purposes, right? So while building components, ask yourself this: the three W's and the H. Though, what component is it? Why, where, when, and how will this particular component be used? If you can justify and check all of the boxes saying this component is incredibly useful, can be used in all of these places, can be used this often for certain design elements, and this is the reason why this needs to be a specific component in itself. And like, is there a reason why this can't be solved with some generic component out of the box that you've got? That's when you can truly justify saying this component needs to exist. It needs to be part of the design system. There are a lot more takeaways, and we can really dive deep into this. But let's keep it short, and let me switch over to a few pro tips that I will share that we've learned from the process of making mistakes and evolving a design library. Pro tip number one: plan for scale. And by scale, I mean like scale, like that much scale, because you might design a select or a drop down to maybe only have 4 or 5 elements because that's your particular use case. You likely won't, in your product that you've built, you may not have more than like 5 or 10 elements in your drop down. But if you're open sourcing it and making it available to the public, you need to realize that some people can use the same drop down that you've got for like 1,000 items, 10,000 items, 25,000 items. Yeah, so that's the amount of scale that you need to be ready for. In fact, even the items that you've got in your product may eventually grow. So you need to account for things like performance, minimizing re-renders, and even general UX, in fact, because an element designed for like 5 to 10 items may not be as convenient to use for 1,000 items, right? A drop down for 5 items is simple, right? But a drop down, you can just look at it and pick what you want. But if you've got 25,000 items in a drop down, you will need a search bar in there, right? Things like that. So that's the scale that you need to plan for while shipping great component libraries. Another pro tip that I would like to share with you is CLI tools are your friend. So if so ideally you would want to avoid complex setup scenarios, right? With too much boilerplate or too much installation. But if you feel the need that your particular design library needs a good amount of setup, the best way to improve the developer experience here is CLI tools. So you can create your own wizards and whatnot. So things like this, where you could have your install scripts running and like your setup scripts running, and create your own boilerplate. And here are some great commands. Here are some great packages that can help you build these CLI tools. Commando for building the overall structure of these tools. Chalk for changing colors. Lister for running asynchronous tasks parallelly. Execa for executing system commands and things like that. And you can also pair it with the observable from RxJS if you want the true asynchronous task execution. All of these things comprise the developer experience, and that's what I believe makes great design libraries truly great. And that's the secret sauce. So thank you. That's been my talk. You could follow me on my socials, and you could also check out ZenDuty.
Hey, thank you so much. That was a very wholesome talk. I personally learned a lot of things. I have a few questions. So one is,
Go for it.
how can a focus on purpose-driven design enhance the developer experience? That's all.
Tell me the question again.
How
Okay.
can a focus on purpose-driven design enhance DX, developer experience?
Yeah, that's a great question. So, purpose-driven design is, I believe, an incredibly important aspect because often if components are designed without specific purposes in mind, let's say just shipping generic components like multiple alerts and multiple pop-overs out of the box, it creates confusion for the end user. The other developer that's going to use your component library is not going to be sure what component to use, which dialog do I use, which dropdown do I use. Can I replace a dialog with a popover? Right? These are obviously these are questions that we have had with other design libraries. And of course, people are going to have these sort of questions with your design libraries. What is the purpose of a pop-up? What is the purpose of a dialogue? Right? Things like these. So if you design your component libraries with specific solid purposes in mind, saying this is what a popover does, this is where a popover is better, and this is where a dialogue is better, right? And there are with examples to back it up, saying this is what justifies using a dialogue, and this is where a popover is justified. These kind of purpose-driven design decisions are greatly going to enhance the end user's experience, reduce developer frustration, reduce developer confusion, and it will also make sure that people are using your system right. Right? If you've built it for a specific way, people are going to use it that way if it's clear that this is how it's going to be used.
Cool. That
Yeah, I hope that answers it.
that answers my question. One last question. So, what, according to you, are upcoming technologies or practices which will have more significant impact in again on developer experience in design libraries?
Great question. So a big one is going to be maybe Copilot assisted setup and development, right? So things like LLMs and GPTs, I believe are really going to help enhance the developer experience for both setting up libraries as well as building components with libraries. So imagine just being able to give a single prompt and the Copilot or whatever you're using automatically sets it up for you, decides which library to use, builds your component and whatnot, especially simplifies the install processes and things like that. So I feel like that's going to be a big one.
Got it. Thank you so much, Anne. It was lovely talking to you and lovely learning from you. Thank you so much for being part of it.
It's been great. Thank you.
Thank you. Hey everyone, before I say a final goodbye to all of you, I have some announcements to make. The first one is tickets for GeekConf, which is happening, live GeekConf, which is happening on 25th of July this week, are available at 40% discount, and you can use a code that is first 40. Then secondly, I'll again congratulate the team GeekyAnts for building GlueStack UI2 and for their amazing launch for app launch. You can check them out at gluestack.io and then app launch with the k.it and you can experience how amazing these products are. The third one is for all the talks which we had today, their recordings will be available. The single recordings will be available on our YouTube channel shortly. Finally, I would like to conclude the remote day of the GeekConf. It was an amazing day. Thank you so much for joining us. I would like to give a quick shout out to our sponsors and the partners. The conference, the remote day would have been not possible without their support. Thank you so much, all the sponsors and partners, for helping us making this remote day a successful one. And last but not least, thank you all for joining us on this remote day. And I'll see you all on 25th in person, live in Berlin. Thank you so much.
Welcome to the GeekConf.
hundreds of resumes and conducting multiple interviews are time-consuming and resource-heavy tasks. But what if a tool could do this for you? Introducing Hyroscope.ai. With Hyroscope, you can create a JD and an interview in seconds. Let's see how it works. Start by creating your first interview on Hyroscope. Select the job role and key in your work experience requirement. Choose the skills that you are looking for and click on Create Interview. That's it. Your interview is created. Hyroscope.ai sets up an automated interview asking questions in the skill sets that you are looking for. With this, you'll also find that the JD for the job role is ready. Happy with what you see? Click on Publish Interview. Share the job position on LinkedIn, Axe, or any other job platform of your preference.